Okay. Shoaib, can you hear me? Mukesh, am I audible?
Yes, sir. You are very much
Yes,
audible.
sir.
Audible.
Yes,
So
yes, sir.
are we
You are
good to
audible.
go? Are we good to go? Shall we start?
Yes, sir. You can start.
Okay, let me start with a short presentation. Uh, I have a small PPT. Okay. Can you see my screen now?
Yes,
Is
sir.
my screen visible?
Yes,
Yes, sir.
sir.
Yes, sir.
Okay. Let me formally welcome each one of you this morning to this interactive session on 5G labs that have been deployed by Coral Telecom. I don't call it a training session as TCIL had originally planned it to be a training session, because I think we are addressing an august gathering of learned professors, PhD students, and students of some of the best engineering institutes. So let it be an interactive session. There are certain values that Coral can add from the commercial perspective, but I know for sure that technical academic knowledge of the audience here is far higher. So we will confine our discussions essentially to talk about commercial aspects. Now, Government of India has taken this excellent initiative of setting up these 5G labs. In these 5G labs, you have a 5G radio, you have core, you have IMS, you have camera, you have drone, Wi-Fi, IoT, IR, AR, VR devices. Now, I must say at this instance, right in the beginning, that you have an excellent lab setup with all the subsystems that are required to develop a 5G solution or a product. Trust me, at Coral, we have developed many solutions, deployed and taken them to the field, but the facilities available with Coral are quite the same. So, these labs and the students or professors working here have full opportunity to develop solutions. The IMS that is being given to you is the one which is being practically deployed in many metros. Several metros, including Pune, Kanpur, Agra, Bangalore Metro, Calcutta Metro, depend on this IMS for their voice communication. The cameras that have been given were actually deployed in Kumbh. I was myself there. So analytics and Kumbh was an exercise of great proportions. Lot of traffic, lot of monitoring, lot of surveillance of high quality that was required. So same cameras were used. The core we have deployed at Kumbh to provide a PPDR. So for police, we had set up a separate independent 4G communication network. The same core was used there. It was deployed to provide them push to talk services, what's called POC, push to talk over cellular. So instead of walkie talkies, and this was a captive network which was set up, converged with the police communication system there. So all I'm trying to say here is that you have an excellent set of equipment, all the subsystems of the 5G that are required. You can, of course, interact with Coral today and over the next few months or years, where we can work and develop solutions together. Now, what the students can do with all this is learn and develop various applications. You have a SDR, software defined radio. You can tweak the core. The core is an open source core. We use it. So of course we use it with certain tweaks, but please feel free to approach us as Coral Telecom if you want those tweaks. We will definitely help those who are interested in developing solutions. There's a EPC, there's a SIP stack provided. You can integrate multiple non 3GPP devices. So when we're talking about police communication at Kumbh, there were many non 3GPP devices. So they have their own conventional UHF, VHF walkie talkies. So they had to be integrated. You and your labs can integrate various IoT sensors and merge them seamlessly as part of your 5G testbed there. You can make mobile devices talk seamlessly to PABX. So analog telephones which are connected on the PABX, the states, the plain old telephones which are connected, they should work seamlessly with your mobile phones. Do that as an experiment. If students want to interact and learn more on these convergence solutions, feel free to approach Coral. So that's where Coral can add value as a commercial organization where we have developed these commercial solutions. Theoretically, in academics, you and your professors know much more. In fact, you can add to our value and you can add to those areas of technology where Coral has challenges. Typically, when you deploy in any organization or an enterprise, they don't want just a phone talking to another phone. They have systems where they have an operator in between. They have dispatcher consoles. They have various heterogeneous devices like E&M phones, UHF devices. They have public address systems. Now, all these can be integrated as a part of an exercise that students can take up. I'm sure most of you are aware there is a hackathon which has already been launched by Department of Telecom. You can use that hackathon and implement some of these solutions that I'm talking about. In the next couple of slides, I'll not take very much time. I know there are specialized teams of Coral Telecom who will talk about each specific subsystem. Most of the subsystems that have been used in your labs are Indian. So whether it's an IoT gateway or it is a firewall or it's a drone or the mobile phone, the mobile phones are not Indian. The 5G radios, the core, all these are Indian, and you can interact with the OEMs who have designed it. In this particular so-called training program as defined by TCL, we have involved the OEMs, so they will be interacting with you today or in the next 2 days. They would interact and have basic information sharing with you. But if you want specific knowledge on specific component or subsystem, I think these OEMs would be happy to deal and to interact with the students who are inclined in those areas. Coral, at least I, as head of Coral Telecom, offer this opportunity to all of you. If you want to develop solutions, if you want to know anything about details of a product that Coral is doing, we would be happy to share with those who are genuinely interested in learning. Some solutions I'll talk about, convergence. Typically, when you go and install a 4G network or a 5G network in an enterprise, say you go to NTPC, NHPC, or to defense, they don't want these subsystems. They want an integrated, complete solution. So they have their UHF devices, they have their VHF devices, they may have IP phones, they may have audio IP phones, video IP phones, they could have dispatcher consoles. So all these need to work seamlessly. There's a large project of railways. Railways is setting up a 4G and even a 5G telecom network across 70,000 route kilometers. So there are tremendous opportunities to do all these kind of things. Some of these Coral has already done and demonstrated to Indian Railways. There are requirements of these kind of things. So there is a vehicle. In the vehicle, it's a complete 4G network which gets integrated with a satellite terminal. So these kind of vehicles are called mobile integrated network terminals. So there are wired devices, there is 4G, there is 5G, there is UHF, VHF devices, all of them integrated to, say, the Sena Bhavan or the army headquarters at Delhi through a satellite. Idea is to have these mobile communication units which go into jungles, which go into far-flung areas not accessible or not covered. So as we speak, Coral is setting up something similar at Jaisalmer. So Jaisalmer, there is no coverage, there is no public network there, there is no 4G, there's no 5G. So to monitor activity at the border, they want to have their private network. So something like this we are setting up. Of course, that is not connected through satellite, but serious applications and defense, Assam Rifles, NDRF, SDRF would require backhaul connectivity over satellite. So connecting all of them and having a mobile phone talk to a analog phone or to talk to a video IP phone has certain challenges, and there are tweaks required. So you need to play around with the codecs, you need to play around with the algorithms. Now these are the things which are challenges, and they are required to be mastered before you can create solutions for end customers. Use them in hackathon. These mint vehicles which I showed you, then there is a requirement that these mint vehicles should be able to talk to one another, or they should be able to communicate with one another while they are mobile. So there could be possibilities in setting up mobile mesh networks, self-healing mobile mesh. So even if these vehicles are at different vertical heights and are at geographically distant locations, can we create a mobile mesh that 50, 100 of these vehicles moving around in a formation in a battlefield, they can communicate with one another, creating a self-healing mesh. Now, today, these kind of products are, they're extensively used, but there are only two, three companies, typically American, GE, and Raytheon. They supply these kind of mobile mesh networks for integrating these multiple 4G, 5G terminals. So these are opportunities, and you can use or develop parts or complete systems or subsystems under this hackathon program. Another opportunity could be to actually have dispatcher consoles. So map all the devices based on location services, and one should be able to talk to them not by dialing a number, by just drag and drop, or by automatically creating a call to the nearest rescue worker. So we did something like this at Kumbh Mela. So created these dispatcher consoles. So everybody who is going to tomorrow use 4G, 5G networks for setting up private networks would require these kind of geospatial maps which are interactive, which are intelligent, and the calls could be automatically routed, tickets generated. So all these kind of things and many more can be done using the lab facilities that you have. Trust me, most of the things that I'm talking about, you have the pieces of technology to develop at least the initial models or to develop the prototypes. How can we collaborate? PPDR. PPDR is Public Protection and Disaster Relief. Huge program of Government of India where these Tetra phones, all these police that you see security forces at railways, airports, they all have this PTT phones, push to talk phones. Can they be replaced with cellular phones? The world over, that's happening. So there is London Metro, Paris Metro, they've already switched over to push to talk over cellular phones rather than on Tetra devices or DMR devices. Can we develop nibs? Nib is essentially that vehicle that I showed you. That's actually a nib. So nib is a small box which would have a radio, which will have a core, which will have an IMS. So it's a complete network in a small box. So can we develop nibs which are plug and play? So instead of Indian Railways setting up a monolithic switching system which spans across the length and breadth of this country, so instead of having one monolithic system, can we rather have these nibs, each nib handling say 20 kilometers, so 10 kilometers on the right, 10 kilometers on the south direction. So these pluggable nibs, especially again if you have to develop mint vehicles which are communicating seamlessly with one another, you need these kind of nibs which will plug and play into each other, or they will plug and play into central core or IMS networks. If you want a E-Node B or a 4G system on the drone, again, drone is not going to be static, so it will have to seamlessly get plugged into one of the central cores or one of the IMSs. Can we create this mobile mesh, the self-healing mobile mesh, to converge multiple mint vehicles? Can we work towards developing crypto libraries or codecs which support quantum encryption, or encrypt the RTP packets, make them quantum secure? So these are areas and opportunities where labs, students, academia can interact with each other, or they can interact with Coral or other like-minded OEMs who are designing, developing solutions in India. Orchestration models, if railway was to actually deploy the 4G network, is not going to be that simple. There would be areas of congestion. There would have to be some kind of predictive mechanism set up. AI will play a very strong role. If there's an accident in, say, Panipat, traffic is going to go all of a sudden increase there. So the spike of traffic, how do I offload it to the nearest station? So if there's a congestion in Panipat, can I offload it to Chandigarh? Can I offload that traffic to Delhi? And whether it is to be done at the UPA layer, or it has to be done at the MME layer, or it has to be done at the PGW layer. So these are the kind of pieces that we need to work on. We need to have AIs which will orchestrate or which will control each of these subsystems. All these subsystems are available to you in your labs? Can we build e-tilt mechanisms? So beamforming, of course, you don't have antenna and beamforming systems in the labs that are provided, but if there are groups who are interested in beamforming or e-tilt, so yes, most of the stuff is available. The electronics is available, but the beamforming antenna tilt mechanisms will have to be created now, because there is a large commercial requirement for such kind of products. There are requirements for mobile device management. Can I control the mobile which is in the hand of an Indian Army soldier on the border? I need to control. I should be able to delete. I should be able to delete pictures, delete all the messages that he has made, because in the event of that handset falling in the hands of the army, we should be able to monitor, manage here. Can I use it as a bugging device there? If it has fallen into their hands, can I use it as a bugging device? So many such things. I'm just throwing open a few ideas. uh, Tethered drone, again, if you want these kind of drones which work as 4G 5G BTSs, then they need to have seamless plug and play mechanism, because they're not going to be stationary, they're not going to be static. They will have to plug into the nearest BTS or nearest core which is available to them. With that, I will close my part of the narrative. I leave it now to specialists who are going to be taking up the rest of the sessions. They're going to talk about each of the subsystems that are supplied in these labs. Feel free to approach me. Now, these specialists who are going to talk to you are obviously the guys who have worked in Coral Telecom and probably designed, say, the core, or a part of the core, or a part of the IMS or a NMS. So each one of them may not be able to articulate a complete end-to-end solution. Feel free to approach me or Naveen Khanna or Mukesh Upriti for any such larger overviews or umbrella architectures. I take leave of you. If there's any question, I would be happy to answer or handle at this time. Otherwise, feel free. Mukesh will share my email ID with you in case you have any questions. Mukesh,
Thank you very much, sir, for your valuable time. Okay.
thank you and namaste.
Oh,
Thanks.
thank you, sir. सुहेब जी अभी आप शेयरिंग राइट्स नवीन गुप्ता को दे दीजिए प्लीज.
Permission right were given. Please check.
Yes. Now, Naveen, you are taking this session, the architecture.
Should I start? मुकेश सर स्टार्ट कर दूं?
Yes, yes, Naveen,
आवाज आ
please.
रही है? Okay. So these are the key components in our 5G lab. What we have deployed in the in 2026 5G labs. 5G radio, core and IMS. 5G radio is a hardware. Core and IMS is a software. MEC, we have deployed 3 MECs there. MEC Edge, MEC Drone, and MEC Camera. 5G Evolution Board, IoT gateways, and sensors, NMS with dashboard, firewall router, 5G AI camera, CPE, AR/VR, and mobile phones. So I'm going to present the architecture of the 5G lab, which we have deployed in the labs. So this is a diagram of the 5G lab architecture. You can see here there is a rack. In rack there are four components. One is switch of D-Link. It is a L2 manageable switch. One is firewall and router of CosGrid, and two Dell servers. The configuration of Dell server is only having the difference with the hard disk capacities. The upper server, which is used for the core IMS and NMS, having the two hard disk 1.9 TB each, and the lower server, which we are using for the MEC applications, having the six hard disks 1.9 TB. There is a G node B, which is mounted on a pole, and the various equipment which are using which are using SIM to connect to the 5G network, just like IoT gateway, 5G drone, mobile phones, CPE, evolution board, camera, and there is a sensor device, Coral GAN, which having the four type of sensors: light, salt, water, and temperature. The connectivity. The SIMs will be connected over the N1 interface to the G node B, and G node B will be connected to the core via the N2 interface, which is wired Ethernet through the switch. And as you can see in the picture, we have also shown the 5G core components and an IMS as well. The core components are AMF, access and mobility function, NSSF, UDM, UDR, PCF, UPF, and SMF. And these all network function will communicate to each other via the NRF. IP addresses also shown here, which IP address is used for and which IP address and the port is going to use for this particular network function. Similarly, the IMS components, there is a PCSEF, ICSEF, SCSEF, and HSS. In our deployment, IMS having the four nodes: PCSEF, ICSEF, SCSEF, and HSS. So that is how we have deployed the lab. One component is NMS in the upper server for monitoring the lab equipments. Devices available in 5G labs. This is a 5G radio. We are using N78 band, and the channel bandwidth is up to 100 megahertz. Power rating of this radio is 100 milliwatt, and this is 2T2R, 2 transmit and 2 receive. This is the 5G evolution board or development kit. What is the components of this Anubhav 5G evolution board? There is a 5G modem, 12 antenna, including the GPS, some ports, I2C, GPIO for connectivity, connecting for the various components for the future development. What we can do here? First of all, we can take the logs of modem level via the AT commands. So we can analyze the functionality of the modem, 5G modem, through the AT commands. The next component is 5G drone, 5G mini drone. 5G mini drone is having the two type of connectivities. One is Wi-Fi and one is SIM for the 5G. It can process the AI/ML analytics for real-time data processing. So in the UATs, we have shown the MEC applications for the 5G drone for the human detection. Various features are also available in the 5G drone: visual odometry, path planning, PVX software, and GPS denied navigation and VV loss capabilities. What is GPS denied navigation? When you are flying the drone inside the lab, because inside the lab, the GPS signal will not pass through. So, how the drone will navigate itself? There is a obstacle avoidance, 360-degree. It has a proximity that will check the proximity of 2 meter square. If somebody is come closer to the drone will deflect from this path to prevent itself. The payload capacity is up to 500 grams. Geofencing is also possible in the horizontal and vertical directions, which also showed in the UATs. It has a camera for image processing and real-time video streaming. Another component is customer premises equipment, CPE. It is just like the Geo Air Fiber. It has the connectivity for the data via the SIM, the 5G network, and that will create a hotspot. So you can connect your laptops, mobile phones, and you can use the data connectivity via the CP. That will create a local area network. Again, the IoT gateway. What IoT gateway we can do? It having the three SIMs. Currently in UATs we have shown the one SIM, but you can use all the three SIMs for the seamless connectivity of various operators also. And you can also connect this IoT gateway to the cloud. And IoT gateway having a rich functionality of firewall, VPN connectivity. So you can seamlessly connect and transfer the data in reliable manner and secure manner to the other ends. Another component is IoT sensor and software. What we are using in the lab, we have provided the four types of sensor: temperature and humidity, soil sensor, humidity sensor, TDS sensor, can somebody mute your system? Okay. IoT sensors will transmit the data. It has the Raspberry Pi inside it. Upper section is used for the sensors and the lower section is connected with the Raspberry Pi. So Raspberry Pi will convert the data into the IP packets and you can take this IP packets through the Ethernet or through the Wi-Fi and connect it to the evolution board or CPE or IoT gateways, and the data transmission will be taken by the core, and from the core you can take the data to the your NMS or somewhere you want to do. IoT gateway supports a wide range of communication protocols, including Wi-Fi, Bluetooth, Zigbee, and more. This ensures the compatibility with a digital era of IoT devices, making a central point to manage your smart ecosystem. And it can be seamlessly integrated with any of the device like CPE, IoT gateway, evolution board in your lab. Another component is 5G AI camera. Features of the 5G AI camera that can be power up via the PoE and the adapter as well. The 12 volt 1 ampere adapter. It supports the AI ML analytics, which we have shown with the FRS applications and the fire detection applications in the labs. What it can do human detection, intrusion detection, audio detection, object left, object lost, line crossing, and scene changes. It has the capacity of SD card as well, 512 GB, and the wide dynamic range is up to 120 dB. It has one alarm port, one audio port, and one CS port. IoT sensor and software. So here we are showing how we are connected the Coral GAN and transmitting data from Coral GAN to IoT gateway through the Ethernet as well. And through the IoT gateway, this data is going to the core and then to the IMS. Another device we have supplied is AR/VR. The AR/VR device will be connected to the Wi-Fi only. It doesn't have the SIM connectivity. So you can connect it with the CPE or with the IoT gateway or with the hotspot of the mobile phone to reach to the network. What is the capacity of the AR/VR? It has a powerful Qualcomm XR2 processor with Adreno 650 GPU for smooth visuals, and it has a resolution of 3200 into 1600 each, and the refresh rate is 90 hertz. We have also developed the one application for the IoT gateway in MEC Edge, which we have already shown in UAT, and it operates on the Android 12, and it having the 8 GB of RAM and 128 GB of storage, and the battery capacity is 5500 mAh. Another component is firewall and router of CosGrid. What it can do: complete next generation firewall capability that is specifically designed to deliver the best protection and performance for the modern encrypted internet. It can be integrated with uh, NDR, enabling automated threat response and synchronized security to effectively manipulate threat before they can cause any significant damage. It has SD-WAN capability as well and supports various cloud connection for the various cloud applications. IoT gateway which appears. And this is the L2 manageable switch. D-Link DGS 152028 is the model name. and it having the 24 ports of 1 Gbps Ethernet and 4 ports of SFP modules. Performance criteria characteristics: 56 Gbps switching capability it has, and it is a web-based managed platform. So you can manage this switch through the GUI. It has the VLAN support, quality of services, security is also there, and these are the servers which we used in the labs. These are the Dell R750 servers, and the capacity of these servers are it having the 64 GB of RAM, DDR4, and the frequency is 32 megahertz. It has 48 core CPU. I already told you the hardest capacity of both the servers are different. The server number one, which having the capacity of 1.9 TB each of two hard disks, and the second server having the 1.9 TB of SSD of 6. So we are going to present the 5G use cases now. Neil, uh, can you join us?
Good morning, all. My name is Indril Saurabhar. Today, we are going to take a session about all the use cases which have the capability to be executed in your particular lab. These are the this is the index. I'll walk you through all the capabilities that we have in this 5G lab, the use cases which are possible. First of all, I'll just go through what we are going to discuss in this session. First of all, is a 5G camera. We have developed basically two use cases: a real-time fire detection using a 5G camera, and a restricted access control using a 5G camera. Then we'll move on to one of my favorite equipment of the 5G lab, which is 5G evaluation board, also known as Coral Rebuff, in which we are going to use Coral Yarn, which is another product of Coral Telecom, with the 5G evaluation board. Then we are going to display that applications like smart home, smart city, and etc. Do have the possibilities to be executed or be implemented using the equipment which we have provided. The third use case of the EV board, which is automatic 5G evaluation board configuration with bash scripts on Raspberry Pi. And last but not the least, the showstopper, which is the 5G drone, in which we have fabricated two use cases. One of them is a real-time fire detection using a 5G drone, and the another one is a real-time human detection using a 5G drone. So let's start with the 5G camera now. 5G camera, which we have provided in the 5G lab, holds the capability of a lot of things, in which, first of all, we will be able to detect a lot of things. We will be able to take the video stream of it, and we are going to run particular algorithms on it. You get the basic idea of what the capabilities have right now. So let me just go through like an overview of what we are going to display. In this, just imagine that in a particular site or a particular room, a camera has been installed, and if by some unfortunate incident, a fire takes place in that particular area or that room, so that camera will be able to detect the fire and will be able to send alerts or anything like that to a responsible authority or a person of authority, anything like that. First of all, we'll be using in this particular use case which you fabricated. We are going to use a AI powered fire detection using a 5G enabled camera and MEC based VM, which is virtual machine. We are going to use a YOLO V5 and V9, YOLO V5 or V9, depending on your system capabilities for real-time interference. In this, basically, we are going to use. Before you ask, what is YOLO? YOLO is basically a machine learning algorithms, machine learning models, which are it is basically a real-time object detection motion. It is kind of the full form is you only look once. So it gives you a basic overview of what ML models are capable of. Uh, so let's start. It ensures low latency, instant alerts, and remote monitoring, which I just mentioned in my example. To implement all these this particular use case, we're first going to need Ubuntu either 20 or 22, or even works on 24 if you the latest one. It needs resources, 10 plus cores, CPU, 16 gigs of RAM, 100 GB of SSD, which is allotted to that particular MEC. Then we'll be installing dependencies. These are basic Ubuntu commands, which you are quite familiar with. These three commands should install all the dependencies which are needed to implement this use case. This is the static IP for the VM, which can be used to access it. Now we are going to deploy a file detection model. Find and clone a YOLO-based file detection repository. If you're using a Ubuntu system, you just use this git clone the repository URL. It will clone that particular repository. When after that, you will be able to switch to that particular repository, and then after that, just install the particular requirements of it using pip. uh, Majority of these YOLO based algorithms, what will they will do is they are going to link the RTSP, the video stream, and they are going to process continuously some YOLO models on it for fire detection. As soon as a fire is detected, they'll be able to send an alert to any person who has been mentioned in that particular alert system. For the benefits, it has real-time alerts for faster response, low latency processing with MEC for obvious reason, remote monitoring and scalability, which I just mentioned. There are particular challenges and needs of future enhancement in this particular use case also. This dependency requires a stable 5G connection. Like if your 5G connection is a little bit lossy or is not particularly stable, this kind of model will still work, but it will just be able to, it will not be that seamless in my perspective. Second is a majority of these models which are open source right now, they'll be sometimes give false alerts. If you are quite aware, like well versed with the neural networks and other things like that, you do know that we do need a little bit of more refining in all these kind of algorithms to particularly make them suitable for the particular use case like us. And last but not the least, optimization. We use the Edge AI, which is an MEC, for faster inference and improved accuracy. So this is the basic use case for the 5G, the first use case, real-time fire detection using a 5G camera. After this, we'll be moving to the second use case, restricted access control using a 5G camera. This is one of my favorite use cases of the 5G camera. Like many of you must have seen in the particular movie, like Spider-Man or some Blade Runner 2049, something like that. That majority of a area in a movie or a area in a area in an area, a particular restriction is allotted by a protagonist, so that that particular area is off limits to the usual, the and is off limit to the basic people or something like that. So these kind of things can now be implemented using the 5G camera which we have provided. Let me just give you a basic overview. This is an AI powered facial recognition for secure access control. Use the 5G enabled camera and MEC based processing for real time recognition, enhances security and minimizes unauthorized entry and automates access log. The key components of this entire use case will be the 5G enabled camera for obvious reason, MEC server, access control mechanism, an electronic door or lock or something like that, or uh, you get the idea, and a cloud-based database which is optional. It is also able to be replicated on a Lenovo ThinkPad also. Now the key features of this are real-time face recognition ensures only an authorized individual who have the authority to enter that particular area will be able to enter that area. Automated alerts notifying case of unauthorized access attempts, scalable deployment across multiple locations with centralized monitoring. What are the implementation process? We first need to configure the 5G camera and the RTSP stream. The video stream which the camera is recording, we need to uh, take that video stream and put it in an algorithm so it will be able to. Okay. Uh, the 5G camera, the stream which is the video stream which is uh, coming from the 5G camera needs to be processed to an MEC or something like that in order for AI to work its magic across that particular video stream. We need to also configure the database configuration. It stores personal images and access levels. It does not require large space. When we implemented it, we were testing it. You can see it right here. One of my colleagues, Ajay Kushwaha, was a prime example of it. Then we have the real-time monitoring log each case's attempts for security. Like this is a particular image which you are able to see here. Uh, this is a demonstration of 5G lab on JP Institute of Technology, in which For example, we took the authority to put Mr. Ajay Kushwaha in an unauthorized person to enter that particular lab, and his logs were present there right here in the log section. And along with that, these logs, an alert system will also be provided to someone who is of higher authority. These are the basic challenges. Network latency issues. It ensures the 5G connectivity. It will not work if you have a lossy 5G connectivity. False positive and negatives. Optimize AF with better data sets for obvious reasons. The RTSP streaming issue. Sometimes the 5G camera's stream gets lossy, or sometimes it gets a little bit messy. So during that case, one in a million chances there that it might send a false alert, but the chances of it is still quite low. The future enhancements are still open there. Edge AI for integration for even faster recognition, improved AI training for better accuracy, and cloud-based analytics for enhanced monitoring. I think the future enhancement is the limit, is in which the sky is the limit, and I think the professors and the students of the respective labs will be able to enhance it even more. Now we'll be moving on to one of my favorite parts. This is the 5G evaluation board, which is also known as Coral Anubhav. In this, what we are going to do, we are going to take Coral Gyan and we are going to transmit the data of Coral Gyan. Coral Gyan as a system does not have any kind of connection with the radio or the server. For in order to transmit the data of Coral Gyan, we need to use a 5G EV board. The 5G EV board does have a connection with the radio, and thus it will be able to transmit the data of Coral Gyan to the Coral Anubhav, and that Kurumba will transmit the data to the 5G radio, and that 5G radio will display the data on the NMS. I have given you a basic overview of what exactly is happening behind a basic skeleton of what is happening. So let me just give you an overview. Coral Yarn transmits sensor data via 5G board to the NMS over a 5G network. Wirelessly connectivity is essential for data transmission. Like the Coral GAN can also use a Wi-Fi transmission, which is emitted by the Coral number. It emits a mobile hotspot, which is a QSoft AP. We are going to connect the Coral GAN to the Coral number of QSoft AP, and then it will be able to route the data to the 5G radio, and that radio will display it to the NMS GUI. So, what are the requirements? We should be able to access Coral GAN IP address. We should be aware of what is the IP address of Coral GAN, username of Coral GAN, and password of Coral GAN is required. Just make sure that Coral GAN has a Wi-Fi module or a wireless dongle. Both of it will work seamlessly. After that, we will be turning on the Coral GAN and accessing the terminal. This particular command will open the configuration file in which you can change the configuration of this Coral GAN. It is quite similar to a BIOS setting in a computer, but it is quite easy to navigate. Navigate to system options, wireless LAN, enter the SSID. SSID is nothing but the name of the Wi-Fi, which will be QSoft AP, and the password. Password is of the QSoft AP, as from my knowledge goes, is between 0 to 9. 1 to 9. Okay, 1 to 9. After that, the data transmission process will start. Coral GAN will be connected to the Coral Anubhav, and that Coral Anubhav will transmit data to the 5G radio, and that 5G radio will transmit data to the server, and that server will display the data on the NMS GUI. Data transmission process happens like this: connect the Coral GAN to Wi-Fi using configuration set. Sensor data is collected from connected device. 5G evaluation board transmit data securely over the 5G network. Data reaches NMS for monitoring and analysis. This is just a basic written theory. I have tried my best to explain all this in a much more layman terms. In key consideration troubleshooting, check Wi-Fi connection, ensure the SSID, QSoft AP, and password are correct. Verify 5G evaluation board setup. Make sure Coral GAN is properly integrated with the EV board. Mobile data transfer. Use logs to verify transmission on NMS. If anyone is from a development background, they must know that how important logs are to check how transmission is happening. Conclusion is efficient data transmission using Coral GAN plus 5G EV board and real-time monitoring analytics via 5G network, and scalable for IoT application and edge computing. With this, I'll wrap up the first use case of 5G EV board. After that, we'll be moving on to another use case, which is a smart homes and smart city applications using the 5G EV board. In this, we are going to use a Raspberry Pi, which is a low-cost, versatile device for IoT applications used in smart home, smart city, and smart agriculture to collect and transmit sensor data. You can use smoke sensor, gas leak sensor, and fire detection sensor. Just imagine that you are a builder, and for some reasons you need a little bit of uh, precaution in your particular flats or something like that. So you'll be installing a gas leak sensor, a smoke sensor, and a fire detection sensor. And as soon as that particular sensor is emitted, the data will reach to Raspberry Pi, and Raspberry Pi will transmit that data to Cora Anubhav, and Cora Anubhav will transmit, will run some algorithm or give alert to this MEC server or anything like that, and that gas leak or a fire will be detected. How it particularly works? A Raspberry Pi, which is a small embedded system, which has the capability to connect different sensors, has a smoke sensor, gas leak sensor, and fire detection sensor, and that data is sent to the cloud server via Wi-Fi or 5G AV board, depending on how you want to configure it. Enables automation and real-time monitoring for smart applications. I have tried my best, everyone, to explain all this in a much more layman terms, because if I come here and just read all this PPT, it will not make much sense, and it will not make the session interactive. The setup and connectivity: Raspberry Pi is configured to a Wi-Fi or a 5G EV board. Make sure the 5G EV board is connected with the Raspberry Pi. Sensors are connected to the Raspberry Pi for obvious reason. And a Python script collects real-time sensor data, and data is transmitted to server or NMS. The server processes and store the data for analysis. I think I've given from my side the best representation of how exactly everything is working. Now we're moving towards the application benefits. Smart homes automates appliances, security, climate control, smart city, air quality monitoring, traffic optimization, energy management, smart agriculture, monitors soil moisture, controls irrigation, optimizes farming. In all these things, EV board has the use case limits, which is a sky. And this we have the 5G automatic 5G evaluation board configuration with bash scripts. We'll be able to run the bash script. This is the basic overlay, the board of the Corona above. In this, will be automates 5G evaluation board setup on Raspberry Pi using bash scripts, enable manual configuration, and ensures faster deployment and reduce errors. Ideal for IoT application, industrial automation, and research projects. What are the prerequisites? Raspberry Pi with the USB support for obvious reasons, 5G evaluation board, and a SIM card. 5G evaluation board is for basic transmission of data, and SIM card is basically connection, establishing the connection with the 5G network. A minicom or a SOCAD for serial communication, and USB to serial driver, depending on the use case or the requirement if needed. To run all this, just first of all, run as root sudo I, check if device part is there, ls dev tt usb asterisk. This basically gives you all the basic USB ports which are available there, and then you'll be able to select the AV port. Install the required packages, which is sudo apt update, which is a basic update command for the Linux, and sudo apt install via SOCAD. This will install the SOCAD dependency from the Maven repository. Grant USB permissions, sudo chmod 77 dev tty usb. Depending on which port you are using on the particular USB port, this might change chmod 777. In all this, what is the key features? Hands-free setup, no need for manual command execution, faster deployment, reduced setup time for 5G connectivity, error reduction, minimizes human mistake in modem configuration, on auto restart on failure, system end ensures continuous operation. How it works: Raspberry Pi runs a predefined bash commands to configure the modem. The script automates network registration, modem setup. A system and service ensures the script runs automatically on boot. The modem continuously operates without manual intervention. Basically, just imagine that in a particular scenario, you need to run different modem settings for different users, and depending on some particular software. To particularly use that, just make sure that if a particular user's logins, then run this bash script. If a particular VIP person logins, then run this bash script. And after that, that particular bash script will configure the 5G board or the modem, depending on the user's priority or his level of authority. Let me just conclude it. Automatic 5G modem setup improves efficiency and reliability. It usually eliminates the human error completely, reduces downtime, and ensures seamless IoT and industrial applications, and easy to implement using bash scripting and system and services. Just make sure that when you're properly writing the bash script, just make sure that you're properly doing the BVA, which is a boundary value analysis. Because majority of the time when we have developed this use case, we were facing some issues in BVA, which is the boundary value. We were not able to consider some particular scenarios in that particular bash scripts. Now we'll go into one of the favorite equipments of everyone, which is the 5G drone, which is the real showstopper of the 5G labs. This we are going to detect a fire detection using this 5G drone. Basically, what we are going to do is we are going to take the RTSP stream of the 5G drone, and we are going to transmit it to the server, and that particular server uh, or the MEC is going to run a particular algorithm in which it will be able to analyze frame by frame, and if it is detecting a fire in that particular area, it will send an alert or inform the uh, responsible authorities. How it will work? It will use a 5G enabled drone, which has been provided by us in the 5G lab, and MEC, multi access edge computing, server for real time fire detection, and AI powered analysis using YOLO V5 or V9, ensures low latency and high accuracy detection, ideal for industrial, commercial, and remote areas as surveillance. Imagine you are a factory owner or a person who has a large scale deployment of some factories or an industry, and to monitor that particular area for some fire or something like that, you can do that by particularly using this drone. Like if in a particular factory, if there's a fire, uh, the human interaction of it, all that will take a lot of time, and it might even cause some unnecessary harm to your particular resources. But with this 5G drone and fire detection algorithm, you will not be needing this human human need, and you will be able to call the fire department with just a first instant of fire detection. uh, to set up all this, we'll be first setting a virtual machine on the MEC server, Ubuntu 20 22.04. Both of them are quite stable. You can also use a 24 one, which I'm using right now. Resources will be a CPU of 10 cores is recommended, 8 plus for real-time processing, which is the basic prerequisites. A RAM of 12 GB is usually recommended, but usually 16 gigs of 16 gigs or higher is recommended. But if you are trying to implement this particular use case, I'll prefer to go with the 32 gigabytes. It will make your system entirely future-proof. The recommended storage is here is 100 gigs of SSD, but if you're taking my advice or my consideration, just go for a 512 gigabytes of SSD, as these kind of things are evolving quite rapidly, and for to make it future proof, just consider my request. Establish a network connectivity of the 5G drone. The drone streams a video over RTSP, real-time streaming protocol. Configure VM with the static IP to communicate with 5G core gateway. These are the particular IP subnet mask and gateway for you to properly route it. Implement a fire detection system. You can use any open source algorithm, open source repository, and open source system, and then you will be able to implement that particular algorithm with the 5G drone. Usually, these algorithms just require a TSP stream from anywhere, and they will be able to detect it, the fire in real times. Equipped with the HD thermal camera, the 5G drone setup is equipped with the HD thermal camera, streams real-time surveillance footage, AI-powered fire detection, MEC processes, server processes live video streams using YOLO, which is AI-trained models for fire detection, and detects flames and triggers visual alerts in real time. Conclusion of it is high speed, low latency surveillance, which I just mentioned. AI detects fire hazards instantly, real time alerts, immediate response to potential hazards. Remote monitoring, seamless RTSP stream over 5G. Wide application, ideal for industrial, commercial, and remote safety monitoring. And feature optimization, edge AI integration for faster on-device processing, and enhanced AI model training for improved detection accuracy. From my end, I tried my best to explain this use case to you fine people. If any questions are there, we'll discuss all this in the end of the PPT. 5G drone. The last use case is the remote detection using a 5G drone. In this overview, basically, but sometimes the governments usually just put some curfew or something like that. So, and that particular time, the police men or uh, the police constables are not able to be present in all the areas at the same time. And this, the 5G drone comes into place with this. The 5G drone will be able to monitor that area, and if anywhere in some particular area or something like that. If there are more than 4 or 3 people, it will be able to detect human detection, and it will be able to detect humans. And based on some the protocols or the priority which has been set by the uh, government or something like that, if they are violating it, it might send an alert, and those people will be handed to authorities. Use a 5G enabled drone and an MEC multi access edge computing server for real time human detection. AI powered YOLO V5 or V9 model ensures low latency and high accuracy in tracking, and ideal for security, surveillance, and access control, which I just mentioned in my layman example. How we'll be setting it up? We'll first set up a VM on a MEC server. Uh, Basic 10 cores, 8 plus is recommended, 12 gigs of RAM, 16 gigs, storage is 100 gigs of SSD. Then install libraries like AI libraries, dependencies, OpenCV, NumPy, and all that, depending on your use case implementation. And optionally, use a Docker inside the VM for flexibility. Uh, Establish a network connectivity with the 5G drone. The drone streams video RTSP stream, the real-time streaming protocol. And after that, configure the VM, the static IP, which is just mentioned here. The IP is mentioned, subnet mask, and gateway. After that, just implement a AI-based human detection model deployment. Select the right AI model. Uses YOLO V5 or V9, trained for human detection from aerial views. In the example on the right-hand side, you will be able to see that humans have been detected in 3 humans have been detected in this particular restaurant or something like that. And after that, uh, we are going to differentiate between backgrounds and humans and background elements. The real-time processing on MAC AI model analyzes the RTSP video feed in real time, detects human presence, track movements, and flag anomalies, ensure security alerts to access control-based detections. And after that, I've given you a basic overview on how to implement all these particular use cases. Let me just wind it up and conclude what we have done till now. Uh, Fast and accurate surveillance is using AI enhances security and monitoring. In the first layman example, which I said. After that, we'll be able to send real-time alerts, detects unauthorized individuals instantly. 5G powered streaming. All this is possible that the RTSP stream coming to the MEC server then sending alerts. All this is possible because of the 5G network, and scalable and security, ideal for industrial, commercial, and security applications, which I just explained in my layman example. What are the future optimization? Enhanced AI training for improved detection accuracy and integration with biometric recognition for access control. And with all this, I would like to conclude all the use cases of all the basic use case of the 5G lab has been concluded. I'll now pass it to my senior, Mr. Sunil Nair. Mr. Sunil Nair, please take the stage.
Good morning to all of you. Now the session is for protocol deployment, that is configuring core networks, functions, and network node connectivity in 5G, which is the main subject in our 5G lab. So Mr. Navjoti will join now, and that is the main session in protocol deployment. So it will start by Navjoti. Navjoti sir, you can start now.
Yes,
Shoaib
sir.
sir,
Can I?
Yeah, please.
Shoaib sir, hello Shoaib sir, Shoaib sir, are you
Yes.
there?
Yeah, one
Yes,
second.
yes.
Can you just give the access to Navjoti
Navjyoti,
ji?
Naveen Jyoti. Okay. हाँ, बोलो. बोल. हो गया, हो गया. Hello, good morning all. Am I audible?
Yes, Navjyoti, you are audible. Please go
Okay,
ahead.
sir. So we are going with our subject protocol deployment and configuration of servers.
And
So
Navjyoti,
this
please
is
make it big. Please make it this presentation in presentation mode. No, 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 no. The this one. Yeah. Thank you.
sure. So our main subject is protocol deployment on the servers. So in the 5G lab, we have deployed the 5G core, which has various components like AMF, NRF, NSSF, and some other component like SMF and UPF. All these are handling our protocol, means all these are handling our signaling and control of user plane packets over the protocols. So there are some protocols we are going to discuss about the session. In 5G, protocol deployment involves installing and configuring core network functions. All required protocols are bundled into a single ISO image for simplified deployment. In our case, what we have done, we have taken a base OS based on Debian, and we have created our own ISO which included all the 5G components, and it has its own configuration. So for the configuration, we have created a single file named Coral. In that, we are going to define all our entire subsystem configuration like AMF configuration and NSSF configuration, or whatever our P11 ID is, tracking area code, all these configuration we are going to define in a single file. So through that single file, we are able to configure our entire system. Here we are going to discuss about control plane protocol. What actually control plane protocol is? It is responsible for signaling and controlling the information only. So it has various type of protocols like NAS protocol, NJP protocol, HTTP protocol, and PFCP protocol. So we will discuss in the detail. And here we are having some plane protocol. So in user plane protocol, it handle actual user transmission. Like after the signaling is happened and the connection established between the core and the user equipment, then its data going through the user plane protocols. So for that protocol, we are using GPRS tunneling protocol. So we called it as a GTPU. So there is one another protocol which helps various type of 5G services to communicate with each other, and that is happening on a unified authentication protocol called as a HTTP. So in the 5G, we are using HTTP2 protocol over the service-based interfaces. So our first protocol is NAS protocol. Basically, NAS is it is a functional protocol that help you to exchange the information between the UE and the core network functions like AMF. AMF is the first entry point for the UE. So whenever UE have to access the core network, it has to connect through the AMF. So that is comes under the control plane protocols, and the protocol is NAS. So NAS operates independently of the RAN radio access network and is responsible for UI authentication, mobility management, session management. So once UI is going to authenticate itself with the core network, then it is going. There are some various type of steps like authentication process, then authentication completed, then security mode command, and all this type of process is going to happen over the NAS protocol. So this is the basic Wireshark capture, where you have initiated a initial UI message where it want to connect to the core network. Then core network asked you for the authentication. Then you have completed its authentication. Then there is security mode command. Then you will authenticate it as a security mode command where it will exchange its IMEI number with the core. Then some various type of things like registering to the network, then PDU session establishment, then user plane data, and all these type of things. So NGP is the next generation application protocol. It is the communication between Node B and AMF. So Node B is next generation Node B we already know, and AMF is the access mobility management function, which handles all the mobility related things of the UE. So NJP is used for UE registration, then mobility management, and then PDU session establishment, and all those things. Our previous protocol NAS is running over the NJP, and then NGP is running over the HTTP protocol. HTTP is a TCP connection between the core network and the end devices or radio network. So this will help us to bind a socket between the two equipment, and then all the protocol running over that sockets. So this is the next wire capture, same wire capture only, where NAS protocol is running along with the NGP, which is between the G node V and the core network, and the NAS are the packets which comes from the UE. Then there is a PFCP protocol. PFCP is packet forwarding control protocol. It is the communication between the SMF and the UPF. What actually it does, when a UE is going to connect, and then we have to create the channels for the UE or sessions for the UE, then SMF instruct UPF to create those sessions over the PFCP protocol. So it is actually control the establishment, modification, deletion of PDU session. PDU is a packet data unit, and it manages QoS policy and traffic rules. Then this is the PFCP Visor capture, where PFCP protocol is exchanged between the UPF and the SMF. First, what UPF and SMF will do, they will communicate with each other and create a PFCP connection, where whenever a UE activity happen, then SMF will instruct the UPF, and the UPF can give the this response to the SMF that this works happens or not. Always there is a heartbeat of the every method, like whatever protocol we are going to use, HTTP2 or PFCP, whatever we are going to use, there is a heartbeat like that. Both the node can be know that there is a still a connection or connection breaks for that. Then there is a HTTP protocol, stream control transmission protocol, transport led protocol of NJP communication, and then it provide a reliable message delivery between G node B and the AMF, support multi-streaming and prevent head of line blocking. So all our communication is running over the HTTP. Through the NJP protocol, it exchanges the message coming from the UE over the NAS protocol. So there is a HTTP protocol wire side capture, where HTTP association is happening between the G node B and the core, and after that their heartbeat and their acknowledgement packages keep on going exchange between the G node B and the core network. Then there is a GTP protocol, where we are going to create the session between the UE and the core network, and there is a GTP connection. Whenever UE will connect to the core network, it will initiate a GTP connection, and then GTP tunnel will establish between the core network and the UE, and then all the control plane messages coming over the GTP only. It transfer user data between G node B and the UPF, encapsulate IP packets for tunneling over the 5G network, carries both DL and uplink traffics. So these are the sample packets of GTP protocol, where all these type of packets coming from the UE, whether it is SC packet, it is a DNS query, or any type of packet is coming from the UE, coming over the GTP. But this is happening after the control messages. First, control signaling will continue. Once the control signaling complete, then this particular GTP connection will establish between the UE and the core network, and then UE can send this packet over the GTP. Then there is a protocol HTTP2, widely known in the 5G network. It introduced in the 5G only. So what we are doing in the previous networks, what we are using the reference based architecture in the previous network, where all the nodes are connecting to each other via the static endpoints, like reference based architecture. So all nodes know that create a static connection between both the nodes, and then they are in the previous. So it is a unified communication protocol. So here, what nodes are doing, all the network functions are communicating with each other over the HTTP2. So it is a stateless connection. They didn't need to maintain the state of every connection. Whenever they require, they can initiate a connection, and they can get the information, or they can put their information, or they can restore their information. Whatever required to the need, they can do over the HTTP2 protocol. Used for signaling between the NFs in service-based architecture. So wherever we are using HTTP2, it is called as a service-based architecture. All the network functions are behaving as a service. They are independently. They don't have dependency on each other network. Whoever need to work with other network function can communicate through a central network function called as a NRF. So NRF in 5G network is a network repository function where all the network functions are going to register themselves and getting the information about the serving network function which they require for a particular service through the NRF. This HTTP2 used for signaling between NFs in service-based architecture, then its support efficient and multiplex data communication, enable faster session managements. This is the some sample packets of HTTP2 protocol over the 5G network. Then network node connectivity in 5G. So how our all the nodes are going to connect with each other in the 5G network. 5G core net connectivity service-based architecture. So SBI uses a service-based architecture. NF expose services that over NF can consume. HTTP2 over TCP/TLS is a primary protocol used for communication, enable efficient multiplex and secure signaling between network functions. So, in this particular thing, what we want to say that, uh, like, if I have created a network function called ABC, and I support two type of services, so I will register myself with the central repository and then expose that I am supporting these two services. Whoever is required these two services can consume from my service. So the best example is like NSSF. NSSF is going to register over the NRF. Whenever 5G services require the slicing, particular slicing, then they can know which NSSF is supporting which slice. Like I have two NSSF in my network. One is supporting slice 1 and 2, and another one is deployed for like IoT devices and support slicing like 3 MMTC slice. So based on the requirement, we can go to the NRF and ask to NRF that which network function I have to call for this particular slice or particular service. So this is the basic the service-based interface is doing. So whenever like when you is going to register with the AMF, then AMF require authentication. So based on the authentication protocol, or we can say based on the authentication algorithm, like I have deployed two AUSF. One AUSF is supporting Milnage algorithm in 5G for authentication, and one another is supporting Snow 3G, suppose like that, or XOR algorithm. So based on the requirement, it can select the AUSF from the NRF that you have initiated a connection and it want a Milnage algorithm. Then it can select the Milnage algorithm AUSF through this NRF. So this is actually best service-based interfaces are doing. Then another one activity is reference-based interface. So in reference-based interface uses point-to-point communication between specific network functions. Like I have to go to a for the authentication, so I know the IP address of the AUSF and I directly communicate with that AUSF whether it's for particular algorithm or not. That is the reference-based interface where we are going to tightly coupled the network functions, means they are tightly coupled with each other, whether what they are supporting or not without knowing that. Then ensure backward compatibility with LTE or APC for seamless interlocking. So reference point architecture we still require for these type of things wherever we want this 4G and 5G to work with together, means wherever we require backward compatibility there this reference based interfaces are coming into the pictures. Utilize GTPU for user plane data transfer between UPF. UPF and SMF connection is still a reference-based interface where UPF and SMF is tightly coupled with each other. So each SMF knows which UPF it has to use or which particular one or two UPF it has to use based on the static thing, static configurations. Then there is 5G core description. There are some interfaces we have talked about. So means between the UE to RAN and then UE to SMF, AMF. All these are the reference-based interfaces. UE to RAN, there is a UU interface we call. Means this is a wireless interface called as a UU interface. This is happening the connection between the UE to RAN wherever they are authenticating themselves with the radio access network, or they are getting information of the radio access network. So then from UE to AMF there is N1 interface where you is sending their NJP or NAS messages. Then there is N2 interface between the radio and the AMF, and when radio is going to connect with the AMF, then it is sending their packet to the N2 interface if it is a reference based interface. Then there is a N3 interface between the RAN and the UPF where all the user plane association is happening. That is the N3 interface. Then N4 interface between the SMF and UPF where our PFCP protocol is running, where SMF is instructing UPF to do the particular video session establishment or other type of activity or any session management or any GTP connection it has to establish. Then it is happening over the N4 interface. Then for policy authorization, there is N5 interface. It can be between any type of application function. Suppose like that in our case, it is IMS. IMS is an application function. Wherever IMS is required the particular type of class of services, QoS, or like audio call it is required a QoS1, then it will initiate a connection over the N5 interface towards the PCF. Then it will ask PCF to enforce the policy authorization for the particular session. For audio call it create one, or for video call it will create one and two both. All these type of policy is going to establish between the UPF, this PCF and any type of application function. So like that there is any other application running which can which want a particular type of another type of video sessions, means high priority video or low priority video or streaming type of video, then that application function can initiate this policy authorization to the PCF over the HTTP2, and they can establish a policy through the PCF, then SMF and UPF. All this process can happen over the N5 interface. Then there is another interface called N6. That is the interface wherever you are going to define your gateways, means data network, which data network you have to use. Going to use the interface named as an N6. Then from PCF to SMF, there is interface is N7, where PCF is going to ask SMF for the particular type of session, which type of session it has to establish between the UE or between the core network. It is going to happen over the N7 interface. Then there are various type of other interfaces like N8 interface is there, where they are going to access the user data from the UDM function. Whenever AMF is required the user data to authenticate whether this is a valid user or not, then it is going to access the UDM over the N8 interface. Then if you have deployed to UPF and the packet has to route through the UPF to UPF, they are going to use the N9 interface. Then SMF to UDM, whenever to create a particular session and SMF require the data of any user for which user it has to create, then SMF is going to access the user details from the UDM function. Then it use N10 interface. Then similarly for this video session establishment, when AMF is going to instruct the SMF to create a particular session, then it will use N11 interface. Then for authentication there is N12. Then whenever AUSF is required data from the UDM for authentication, it will use N13 interface. Then if you have multiple core network and you want to interact with each other, interworking of this network, then there is interfaces N14, and then there are two other interfaces N15 and N22. One is used for policy authorization, wherever we are checking which sessions are allowed to this particular user, means which type of service it user has subscribed. So AMF will ask PCF to give those type of services list. So it will happen over the N15 interface and then N22 interface, where AMF and NSSF are going to enforce the slicing, which slice it has to use. Then there is a service-based interface. So similarly, like we are using N1, N2, N3, N4, N5. Whenever we are going to use the HTTP-based or service-based interface, there are interface named as a in the form of API, you can say. So in the form of API like that, for if they have to access the NSSF, any type of module can access the NSSF, like AMF can access the NSSF or SMF can access, or one NSSF can access the another NSSF. So there, to access the NSSF particular function, there is an interface called NSSF. So we have to define that we want to access the function NSSF. So this will, we are going to hit the API with particular thing. Then for NRF, all the network function use this NRF interface, whether it for discovery or whether it for registration to NRF. So all the network function are going to use this particular NRF. We will check all these in WhatsApp packets also how it is happening. Then for PCF there is NPCF. For UDM there is NUDM with the interface name. For any external application you can define NAF or any other application specific name. For AUSF there is an AUSF. Every network function is going to use. It is basically happens between the AMF and AUSF only. Then AMF, where U is going to access the AMF, or G node B going to access, or NSSF, SMF going to access the AMF through the NAMF API endpoints. Similarly for the NSSF. So this is the service-based architecture where we are going to define a particular URL like any domain, then slash NSSF, and then which type of service you want to access from the NSSF. And all these are RESTful API. So RESTful API mechanism is applying to these, like which type of API this we want to post some data, or we want authentication, or we want to get some data. So based on that particular request, this interface is going to define which type of this API we are going to hit, like this is a get type of API, or this is a post type of API, or this is a put type of API. Whenever we want to put some data to the UDM, so we'll use as a put type of API, or we want to ensure our heartbeat, so every heartbeat is having a put type of API. So these all are defined in the 3GPP specification, how we are going to use these particular interfaces. So API for UI context, similarly, like for UI context management, this type of API is there. Like we can put the data slash UI context, create a new UI context whenever we have to create with network function, like AMF is the network function. So we will use the AMF domain slash, then we will use the NAMF, that is the network, this and so this interface name, and which type of communication is this, like this is a communication message, then we will use minus communication, then which version it is having, then v1, and then which type of work we want to do, like UI context management we are going to do, then all it are having UI context, then which type of activity we are going to use with the UI context. If this is a initial create a new context, then we will simply put slash UI context ID, whatever UI context ID we are going to give, like if SOPI we are giving, so slash SOPI we can give, or any other context, like if you want to release any context, or release any EVA to a UI context, or assign any EVA to a UI context, or we want to transfer their context, like UI has created a context with the core network, it is already established. Now any application function want to modify this context, so it can initiate this UI context transfer. So UI context will transfer from the previous context to new context, or we can update the UI context where we are updating the UI registration status. So we can update the UI context, or whenever in case of handover or some other things, we can relocate the UI context, or if we want to cancel, there is a cancel relocation, like we have initiated a relocation and another endpoint is not available, so we can cancel this relocation also. So there is this type of APIs are there. So these are some API for UI context management. Similarly, like here are UI context management, there are some other APIs also. For SMF there are some other API, for AMF there are some other API. This is not the entire list, there are so many other APIs. For every module it has its 5 to 10 type of API, and then their functionality, multiple functionality they are performing with particular APIs. So now we are going to discuss about all the network core network function like AMF and UDM, what actually it does. So this is the access and mobility management function. It performs operation like mobility management, registration management, and connection management. For UE connection, it act as a single entry point. So whenever you have to connect with the core network, it want to access anything from the core network, or it want to access the core network to register itself with the core network. There is a single entry point, is the AMF. It has to come through the AMF only. Suppose like that we can say that in our local network we are having firewall. So any public traffic is coming to our network is coming through the firewall only. So similarly, AMF act as a single entry point to come into the network. So also it is managing mobility of the UE. So it is having all the detail about the mobility of the UE, like when UE has initiated its last location, wherever it was last time, from which node it is connecting, what is the context ID, which context is remaining. As soon as UE is losing its connection with the core network, it will initiate a paging messages. It will start paging with the UE, like where is the UE? It didn't get any information from a time below. So there is already a time defined. So whenever UE is going to keep on update their location area update, so this we called in the 5G as a TAU. So tracking area update always UE is going to publish with the core network. So based on that, core network will know that this UE is still existing with the core network, or it has lost its connection with the core network. Also, AMF select the corresponding SMF for the management of user session context based on the service request by the customer. So which type of services is going to initiated from the UE, whether it's for data network, whether it is for some other type of network, or like we can say usually we have deployed in the lab two type of network. One is data network and another one is for IMS signalings. So two type of network we are handling in already in the 5G lab. So based on the request, it will select which network it has, which SMF it has to select. Like one SMF is handling only IMS session. So for IMS signaling, it will go to particular SMF, and for data signaling, will go to another SMF based on the UE context. So it will manage all the sessions. When compared with 4G EPC, its functionality resemble with MME of 4G network. Like in the 4G network, we were having the MME, where MME is handling all the mobility related things. Along with this authentication also done from the MME only in the previous protocols. So here we have its functionality is similar with the MME except the authentication. Then there is the session management function. It performs operation like session management. So it will manage all the session between the UE and the core network. Then it will allocate the IP address to the UE, and it will manage all those UEs. So for which network it has to assign which IP address, so all this is handled by the SMF. Then based on the request from the UE, it will select the UPF. So which user plane function it has to select for this particular bar, it is going to select through the SMF only. Then QS and policy information for control plane used for service registration, discovery, establishment. All this is also done by the SMF. So enforcement is done by the SMF and implementation is done by the UPF for this QS and policy enforcement. It functionality resemble with HDWC, MME and PGW in the 4G network, where compared with 4G APC. So in 4G APC, all these 2-3 works are done from 2-3 other components. Here SMF is handling all these things. In the 4G, MME is handling this session management. Then PGWC, MME is handling its UE management. Then HDWC is handling the session control messages. and PGWC is handling this packet gateway type of message like IP address allocation and all these type of things. So all these three functionality is converted into a single module in the SMF. So in the 5G network, SMF is handling all these three four functionalities. Then there is another major this network function called as UPF, user plane function. It maintains video session, perform packet routing, forwarding packet inspection, policy enforcement for user plane, QoS handling. All these works is done in the UPF. So in 4G, this QoS and all this work or session management is done from the for the user plane data. It is going to done from the HGWU and PGWU for this IP address forwarding and all this work done in the 4G network. Then in 5G we are having one another module which manages all the user related data. So we called it as a UDM, Unified Data Management. So it only manages the data, it is not storing the data in the 5G network. It performs operations like user identification handling, subscription management, user authentication, access authorization for operation like roaming and etc. In 5G, this work is done from the HSS or AAA functionality, authentication, authorization, accounting. There is a module called as HSS in the 4G network. So the functionality similar to the HSS is managed by the UDM in the 5G network. In 5G network, we have separated HSS into the two parts. One is UDM, one another is UDR. In the 4G, HSS is storing all the user related subscription and it is itself handling all these things. But in 5G, UDR is the repository where we store all the data. Means whatever belongs to the particular which sessions are allowed to the particular user, how many services it can access, or which type of policies we have applied, or any application specific data or any exposure type of data we have stored for a particular user is stored in the UDR but managed by the UDM in the 5G network. It is a central repository where data can be stored, which includes subscription, policy, exposure, and any application specific data. Also in 5G, there are some other things like unstructured data we can store in the UDR, and some other type of things are also there. Then there is a module called AUSF, Authentication Server Function. It allows the AMF to authenticate the UE. When compared with 4G EPC, its functionality resembles with HSS AAA server of 4G network. So whenever MME require authentication in the 4G, it will go to HSS and ask for the authentication. In the 5G, we have created a separate module called AUSF. So whenever AMF require the authentication of a particular UE, so like in the voice capture, we have seen once initially the message comes, then authentication request is going. So AUSF is providing all the data related to authentication, like what can be the random number, what will be the AU10 value, and key vectors, whatever required for authentication based on the user data. It will create all those vectors and share it with the AMF, and then AMF forward it to the UE for the authentication. So then a response will come from the UE, and we can compare the response and check that whether this UE is valid or not. Then there is another function called network slicing selection function. So which type of network we have to provide the UE? It is maintained by the NSSF. It maintain a list of the operator defined network slicing instances, like which type of functionality this UE can perform. It defined in the NSSF. Which type of connectivity it will get. Based on the subscription information stored in the UDM, AMF authorize the use of network slicing. Then based on the service requirement, it can also query NSSF to authorize access to the network slice. Then NSSF redirects the traffic to an intended network slice. Like I have three type of slicing in my core network function. So three are the basic slicing in 5G network which are defined. One for EMBB, which we call as a enhanced mobile broadband, and widely used for data communication only. Wherever you have to use the data network, then you are going to use the EMBB slice. Then there are two other slices. One is for IoT devices and another is for time sensitive services. For IoT devices, we are using the slice 3 called as a MMTC, and for this delay sensitive services, say like push to talk or some other things, we are going to use the slice called as a URLC slice 2. So EMBB, we all people are going widely used in our mobile network where we are using mobile data. So it all running over the EMBB slice only, enhanced multimedia broadband. Then URLLC, we are means normal users are not going to use, but for a specific particular services like disaster management and all these type of for all these type of services, we can use this URLLC. And wherever we required n number of devices, means thousands of devices we required to manage, but data throughput is not required as much, but connection management is required. There we are going to use MMTC, massive machine type communication we are going to use in that particular things, and we can use the slice MMTC slice 3. So slicing selection function can provide all these slice. So in the WASRC we can check which slice is assigned to this particular UI or which slice we have to assign. We can configure all these things and we can initiate these requests. Then there is one another module called network exposure function. It exposes services and resource over API within and outside the 5G core network. So what NF actually does, it become a part of 5G core network as a module. So it can register itself with the NRF or service communication proxy. So it will register itself with the 5G core network. After registering, so if any third party application require any particular type of data which 5G core network willing to expose, like how many UEs are connected with my core network. So all these type of functionality can be run through the NAF from the outside of the network or within the network also we can run all these. Like we have deployed NMS, so where we want to check which UE is alive, which UE is not alive. So through the NAF we can expose all these functionality which is connected with the core network, or which activity is happening or which analytics is happening on the core network can be provided to any third party applications. So for a simple example, like if we want to expose this policy enforcement from the outside network or any application function, like there is any mission critical application which require a high policy control, means high 5K value it needed instead of data network it needed mine, suppose like that for data it requires 70 5K value. So it can be enforced through the NEF. It can call the NEF to access or export those capability from the 5G core network, and then core network connected with the PCF, and this policy enforcement can be done. With the help of NEF, third-party application can also access the 5G services. So like that we have discussed, PCF service we have discussed. So this is the similar thing. Other core network can also be exposed using the NEF. So if any other functionality like session management or user context management or user data repository or any specific application want to store its unstructured data, so UDR repository or UDM repository we can expose through the NEF. So that is depending on the implementation how we are going to deploy this 5G core network and how many functionality we are going to expose through the NEF to the third party application, and also depending on the need of the applications. And then this is the main function of the 5G core network, which maintain all the other core network functions and their functionality. So NRF is enough repository function where all the network functions are going to register themselves, and after that they are exchanging this communication between each other, and then they are exchanging their services. It maintains the list of available network function instances and their profiles. Then, to enable distinct network function to find each other via APIs, it performs service registration and discovery. So what is happening? uh, I have started another function. So then I have started one another function called as a AMF. So AMF will register itself to the NRF, and then if any other network function want to access the AMF, so it can discover it to the NRF, and then NRF will tell that this AMF is available, and then this communication between the AMF and the that particular network function is happened. For example, here when you try to access the service type served by the SMF, AMF discover the SMF which is registered to NRF. So based on service requirement, AMF will discover which SMF it has to initiate the sessions or which is registered to the NRF. If one SMF is there and which is not registered to the NRF and serving a functionality that will not going to be discovered here. So any authorized customer can access the service offered by a registered network function, means producer, since network functions are connected via message bus in SB. Means so if all these are connected in the service-based architecture over HTTP to protocol, unified authentication, all these are supporting, so it can be accessed through the various network function. In the simple language, we can say that like Zepto is the center repository where all the these hotels and all these food restaurants are going to register themselves. So if any user has a requirement of particular thing, it can access via the Zepto. So Zepto can be the NRF in that particular case. So it is a central repository which maintain all other network functions like their functionality, what is the name of that network function, which services it is supporting. All these are managed by the NRF. Then there is a policy control function in 5G network. So it support policy control framework, applying policy decision, accessing subscription information, etc. to govern the network behavior. In policy network function, it is doing like how many services a user can access. Like a UI is going to connect to the core network and it is not allowed to access the data network. So all these policies are going to manage by the policy control function. If we compare it with the 4G, in the 4G there is also policy charging and rules function. So PCR we are saying that it is the similar functionality this PCF is behaving in the 5G. So all QS enforcement and all this policy and their charging and their billing is done by the PCRF in 4G and PCF in the 5G network. To govern the network behavior, it supports policy control framework, applying policy decision, accessing subscription information, etc. So means whenever a request come to the PCF, what actually it does is it will access the UDM through UDR through the UDM, and it will check that which are the particular services are allowed to the particular user, and based on that it will applying their policy, and it will enforce the policy based on that, and then SMF and UBF can work based on that policies. It functionality resemble with PCR of 4G network when compared with the 4G EPC. So now I'm going to show you some Visor capture where we can discuss all these network functions. So one by one services I can show you where we will register to the NRF and to other services. So one by one I will show you the live Visor on that based on that. So here I am having a setup of 5G network. So here we are going to run services one by one and check in the WSR how it is going to register. In detail, we will discuss in the another session. We are having log analysis and all these. So here we will talk about the configuration and this basic packets. So our first main network interface is NRF. So first here we are going to access the configuration. So we are having a directory called in OPT Coral 5G is the directory, base directory. In there we are having some type of things like user configuration, all these type of thing and services. So in this etc is the folder where our all the configuration relies. In etc we have to go to Coral 5G folder. Here we are having all these modules. So which type of particular functionality we want to perform. So first we will start with the center repository because all the network functions are going to communicate with the center repository only. So this is the NRF module which we have configured on a particular thing. So this is the NRF module. This is the configuration file of NRF where we have defined this configuration. So in the NRF we have defined its log path here where it will store its logs for analysis. And then in global section we have defined how many messages we can attach with this particular network. So this is the number of UE. It can be increased based on the server specification. So after that there is a tag called as NRF, and in this we have defined which PLM and ID it supports. So which MNC MCC value it supports as defined, and its SBI interface where all other devices can communicate to the NRF. So over the SBI we have defined the IP address 127.0.0.10 and it can communicate over the port 7777. So this is our configuration part of NRF. So whenever we will start NRF, it will start listening on this particular IP and particular port. So any services which want to register on the NRF can connect with this particular network function. So first we will go here. First we will check whether on this port any service is running or not. Like 7777 is the port, no service is running on this particular port in the system. So we will start then NRF and check. So we have started the NRF services. So Core 5G hyphen NRFT dot service is the service name. So it will applying with this particular configuration. So you can check the status here. So this NRF services initialization is done. It started over HTTP on this particular IP and port. So now we can check the port listening. So it will show this particular IP and port is binded to the NRF services. Then we can register our other network functions with the NRF. So this now we can connect another network function like if I want to connect the AMF. So first we will check the AMF configuration. So AMF same the log file path is there, then maximum number of view is there, then SBI interface where it will accept this API interfaces. All the AMF related API can be called via this SBI. Then port is there 7777. Then client who is going to use here and which module it is using. In 5G there are basically two modules. One is SCP. Through SCP you can connect the NRF or directly you can connect the NRF. So based on the configuration you can configure here. If you want to connect through the SCP, you have to define the module name SCP, or if you want to connect with the NRF, you can define it as simply as a NRF and then NRF IP address like .10. If you want to do it with the SCP, you need to define SCP IP, then SCP the module name. In SCP, what you need to do first, then you need to start the SCP module first before the NRF, and SCP have to this SCP have to register to the NRF Then any other network function comes in the picture and connect through the SCP to the NRF. So here is our SCP module. It is dead as of now. It is a stopped services. So first we will check the SCP configuration. So this is our SCP configuration where its SCP log path is there. Then maximum number of UE, how many it can connect. SCP is the module name. Then IP address of SCP on which it has to listen and port. And it has to connect with which client. So it will register itself with the NRF. As earlier we have seen that 127.0.0.10 is the NRF IP and 7777 is the port. So here will be the NRF URL. So we will start the SCP and it will connect to the NRF. So as soon as we have started the SCP, it has requested a message to the NRF IP. Post message that an NRF NFM network function management. Then V1 is the, as we have discussed in the API, that it is the version and then subscription. So it has subscribed to NRF. And based on that, now it's created or not will be the sent to the SCP back through the NRF. And then as NRF, it will provide a instance ID. So now our SCP is registered with the NRF. So any of the network function now need to register on the SCP and SCP will register it to the NRF. So through SCP is a secure communication proxy where we are not exposing our main network repository to the network function. It is registering through the proxy. So called as a SCP is the new concept in release 16 5G network. So now we will start our AMF service and we have configured it to connect with the SCP and then SCP has to connect it with the NRF. So now we have started AMF. So AMF will initiate a request to put their instance ID to the SCP. Then SCP initiate that request to the NRF IP, and then the same configuration is going back through the modules, and they will get registered. Also in the log we can check whether this request has come to the NRF or not. So our log directory, as we have defined in the logs, so here this like two modules it is created. So this subscription based on the module it will create here. So this will the instance ID is going to assign to the every network function through the NRF will show here. Similarly, now we will discuss the all the configuration of other network function and we will start all and check the functionality. Then there is SMF configuration is there. This is our SMF configuration where we have defined the low path. So maximum number of UE, then some parameter IPv, IPv6 in local address packet filter, enable, disable some of the for the backward compatibility of the devices. Then SMF is the module. Its IP address as set it up in the lab, same IP address we are using here also. 127.0.0.4 and 7777 is the network endpoint. So means this IP and port will be the combination for the SBI interface, and this also got registered to the SCP. Then there is one protocol we have discussed, PFCP, packet forwarding control protocol between the UPF and the SMF. So SMF configuration will contain all these IP addresses like SMF IP address, Then which client it has to connect. To UPF it has to connect over the PFCP protocol. Then UPF IP. So this section will contain the information about the connection between the UPF and the SMF. Then this is the generic framework SBI interface. Then there is protocol comes in the is called as a PFCP. Then for GTP connection, it will listen on a GTP IP address. For GTP also, it will listen on a GTP IP address. User plane control plane messages. Some control plane message coming from the network function, and user plane data comes from the UPF. So it will also listen for all those protocols. Then these are some key metrics going to access by other network functions. Then how many session it can support. So it is supporting basically two type of session. One is for internet, one is for IMS. So it will manage uh, two particular session, and also IP assignment it has to do. So from this series 10.4500/16, it will start assigning the IP. Gateway it will define as a 0.1. So SMF will start listening on 0.1. It will treat it as a gateway for the user. So user will get a IP address, then as a gateway they will get these IP addresses. Also for IMS there is separate IP address series, similarly separate gateway, and these are the two virtual interfaces we have defined through where these packets are going to flow. After that, this IMS will provide which DNS server users has to use. So based on our DNS server configuration, we can define here the DNS server IP. So whatever IP we will define here, it will assign to the user. Like this is the DNS server for the particular user. If we want to use the global DNS server like 8.8.8.8, so here we can define the value as a 8.8.8.8. So all the domain resolution, all this will happen based on this DNS from the users. Then maximum transfer unit, the session is going to created from the user. So how many maximum bytes it can transfer. So this is the maximum transfer unit. Then PCSF IP we have defined for the IMS functionality for VNR. So here we will define the PCSF module IP, application function IP. Then these are some parameters. So this is our overall SMF configuration. So now we will start the SMF module also. And some other configuration is also there. There is then PCF configuration for policy and rules function configuration. So database is going to used as a MongoDB database for policy authorization because it has to register with its UDR and UDM. It has to access the data, so it will access the database. Then there is a log file path is there. Then maximum number of view is there. Which SPI interface it will use, which port it will use to connect with the services. So any services want to connect with the PCF over the HTTP2 protocol, they have to use this IP and port. So on which client, this is also going to similarly register with the SCP. Then if you want to export the matrices, like whatever activity is performed by the PCF, so matrices can be deployed to, there is a matrix server. So this is the PCF configuration. Then there is slicing function configuration is there. So NSSF is there. Similarly, log file, then maximum number of UE, its SBI IP interface and port. Then which client it is going to use? It is going to connect with the SCP. Then for particular slice, through which NRF or through which SCP it has to go. Like here we have configured 4 slices we have configured here. So one is SST1, one is SST1 with SD value 0000. Then another is one is SST3 MMTC slice, and another is SST3 with custom value 030609. So these four are we have connected. So here we can give different type of network repository functions IP. So through which we need to access these slices. Like I have two NRF. So one NRF can give me slice 1 and slice 3. Another can give me slice 1 with SD value 00 and SST value 3 and SD value 030609. So all these we can configure here. So for all these slices, it will go to the relevant NRF and network repository function. Then there is AUSF configuration is there for authentication. Similarly, it will listen on a particular IP port and then it will register to the SCP. Whoever have to connect with this AUSF, it can connect with the AUSF through this IP address and port. Through the NRF, NRF will discover all these IP address that we will see in the YSR captures later on. So then there is UPF configuration. UPF is the only part in the 5G network we don't have the SBI interfaces, because UPF has to communicate to the SMF only, and SMF and UPF there is a protocol, PFC, packet forwarding control protocol, which is going to be connect. So here we are going to define only PFCP. SBI interface is not the configuration part here. PFCP and GTPU. So where it is going to create a GTP tunnel between the users and this the UPF. And PFCP from where it has to inform the SM that whether this session has created or this session has some restriction and all this. So this GTP address is used by the device to connect the GTP tunnel. So whatever IP we will define here, so from the device it should be reachable. So it can come here and it can connect its maintain its session and create. So all the session supported by the UPF are here listed, like in the SMF, how many sessions the SMF can support. Like SMF can support three type of different session, and one UPF can support two types of session, and another UPF can support one type of session. Can be configured dynamically. So here we have only one UPF and one SMF. So here we have defined both the session in SMF and UPF. Both the interfaces same IP series, whichever it is going to use, and then some matrix is published by the UPF to the matrix server. Then after UPF, there is configuration of UDR. It basically connect with the database and create a repository, register itself with the this NRF. Then UDM, it will connect with the UDR only. So how many type of authentication scheme it is going to use to create the SOAP and all these values are defined here. So scheme 1, scheme 2, and how many IDs it is supporting, all are defined here. So if we have to enable the TLS, we can enable the TLS over the transport layer. So there is TLS configuration also, which requires certificate and all these things. And then there is some other module called as a BSF. BSF is basically a binding support function which will help us to reconnect with the older protocol, like where we are having diameter and all these protocol. So BSF will help in all these type of things. So all these modules are defined here. So now we are going to start all the services and we'll try to connect a G-Node with the core network and check the connection happen successfully or not. So now we can list down how many services are running. So it will show as a NRF is running, then NSSF, then AUSF, all this service, and this will be the service status, whether it is running or exited or dead or inactive, whatever is the status. Then UDM we have run through SMF, PCF, AMF, and UPF. So all these services we have started. So now we are ready to connect the other other network modules called as Gnode B or user equipment to the network function, and we can check all the things. So we will go to the log file where it will show, and also we will check the wireshark where it will show the message coming from the Gnode B or not. So this is our Gnode B status. This is our log status. We have started the log capture on. This is our Gnode B IP where we have configured Gnode B with this particular core. So we will restart its services. So we have restarted our services. So previous connection lost with the AMF. So it will showing it as a detached request so that Gnode will go detached. So as soon as it will come in the network again, it will create a connection with the AMF over the N2 interface, whatever we have discussed in our initial slides. So we'll check on that. So here we got the request from the Gnode B. So here it will define as the request from which interface GNB N2 is the interface, whatever the IP address of the Gnode B and which port it has connected through. So in the log, all this information will be available. So maximum number of stream it can transmit over the stream, and then we are publishing this statistic to our NMS server, like connected or not of all these of matrices. So in the wireshark also, it will go. There will be a connection over the NGP protocol, which happens between the Gnode B and the core network. So here is the IP address of Gnode B, and then core network it will connect, and then there will be the response. So here it can be successful response or it can be rejected response based on the configuration. Like if so, these wireshark and these logs will help us to identify the issues where it is a configuration issue or some other issue or support issue. So all these wireshark and these logs will be the helpful tool for us. So if we will discuss about all these logs in the later on session we have for this Verserk and logging. So this is the initial message from the GNodeB where GNodeB connect with the core network and it is registered. So there are two type of message. One is ng setup response or another is ng setup failure. So ng setup failure will message will contain it's a obviously it's caused by it is not able to connect with the core network. So now I will register UE and we will check the process whether UE is. So I have connected a UE on the visor. So we can connect from here. So this is the UE. First we will check the information of the UE. There is a tool called this force LT. So here it will show its MC value. So like 001019876543207 and it is in NR only mode. So it is in 5G mode only. We will connect this UV so it can help us to identify the logs and this WhatsApp. As soon as we have connected the UV, it goes the 5G symbol and then for IMS it goes this voltage VNR symbol and these wires are log information we got. So all these are the messages going to flow between the UE and the core network. As we discussed in the initial, there is NGP is the protocol between the radio and the core network. Then this NAS is the protocol between the UE for exchanging control messages, and then the messages are going to exchange with this particular core network. This NAS is like whenever you is initiating a request, it is flagging all these messages with the NAS protocol. So Gnode will let know that this message has to send to the core network or it has to for the access network. So it will. That's why we are using the NAS protocol. So here initially we message and then all the information as we have discussed in the WhatsApp images initially, like identity request and identity response, then downlink nest transport, uplink nest transport, then security mode, and all these messages are going through the all these things. Also, along with these messages, it will I will show you how it is going to happen between the core network functions also. So so as soon as initially message came, core has requested a request for the authentication and AUSF. And AUSF is the API endpoint as we have discussed in the initial discussion. Like this service-based architecture is having interface named as NAMF, NSF, AUSF, NSMF. So these are the interface name and AUSF. Then for which particular service we are initiating it for authentication. Then version and for which type of authentication we are using like UE authentication. Whenever you are going to register, we will initiate a UE authentication to the AUSF. So this is the message initiated to the AUSF. So packet we have received from the based on the AUSF inputs, we have initiated a identity request to the UE like please expose your identity. So UE will initiate it. Then UE will respond with this response like this is my identity and based on that then We will go further with the AUSF, then UDM, UDR, then security information. All these values we will get, and based on this, our entire call flow is going to start. So there is one major part. One is stream ID. So whatever packet we will send, we are going to send with the stream ID, and its response also we have to send like a HTTP to packet which contain a payload like JSON or some other file, XML file or some other type of data it contains. So data also we need to send with the same stream ID. So all these packet can be aligned with each other. That this is the packet for this particular API request. Like here, UI authentication is the API request. Then we have initiated a JSON message. It contains a JSON file where it is having its information like UI data, whatever UI data it is having, or server name, whatever it is having. So all these information we need to attach with both this UI and the API request. Similarly, with another request, one first request will come to the AES app, then another request will go to the UDM because AESF don't have the user data. So for the user data, it has to go to the UDM. So it will go to the UDM, same SBI interface only. So this is the interface name again, NUDM. NUDM is the interface. UI AU is the service name, which service it is going to register. Then it will give the context for which thing it is initiating. So it will give the UE, SUPI, UE, MC or whatever value is there. Then it will ask for the to generate the authentication token. So it will give the security information, then it will ask for the generating of a authentication token. Then once this request will reach to the UDM, then it will get the data from the UDM. Sorry for the delay, I got a call. So then based on this UI authentication, this is the call flow like that. First message will go to the AMF, that is the single entry point. Then second message will go to the AUSF for the authentication, because AUSF is the module which is responsible for authentication. Then AUSF request its message to the UDM to generate some token. Based on that, it can ask for the authentication. So AUSF will ask for the generate auth data to the UDM. Then UDM also don't have the data directly because data is in the 5G network. Data is going to store in the UDR, Unified Data Repository, where all the use related data is going to store. So then it will ask the UDR for the particular thing like MC value and authentication data. So then step by step, however the request flow is there, based on that we are going to get response. Like the last flow with the UDR with the stream ID 87, then the response back is going from the stream ID 87 first. Then before that, whatever request was there, like value 3 is there, then 87 is there, then 3 is there. So last in first out approach is there. So whatever last message will come to the UDR, so it will respond back. So module by module communication is happening. Finally, this response will reach to the AMF, and then AMF will initiate the authentication request based on all these parameters. So all these parameters, whatever it will get from the AUSF back, it will initiate in the this NJP protocol, and next message it will initiate authentication request. Also, it will store its response to the ASF will store its response that this is my 5G confirmation and auth events all it will store. Then whatever message will come in the authentication whether it is a valid UI or whether it is a spurious traffic. Once the UI authentication response match, then it will put its subscription to the UDR that this is a UI now it is got registered. So it will put that request, then it will put to the UDR that this got registered. So now this one subscription is created in the database that one user got registered now, and based on that other functional activity is going to happen, like security mode command. Then once the authentication completed, then for this security server is going to ask the IMEI ISV number to the users. Then it will initiate a security mode command from AMF to the UE. Then security mode command response will come, and then there is a transport is going to happen between the UPF and all these modules. So then there is uplink transport, then there is downlink transport. Once all these transport and will get created, then it is going to initiate a service request. So then in context, then downlink and uplink. After all this successful authentication, all the security mode command and context setup, then this user requirement will initiate a service request. Means how many services it want to use. Like mostly users are going to use data. Then after data, they are going to use IMS services, and if any other type of service is allowed to that. So it will initiate request for all those services. So first it has initiated a request for video session setup request for data. So data is having 5K value 9. It has initiated. Based on that, server will respond whether it is allowed or not. So once video session setup request will come, then video session setup will response will go. So if it is allowed, then it will a successful response. If it is not allowed, then it will a failure response. Then once this will happen, then another video for this IMS it will start. Then video session setup request for IMS activity and its response. After this, user is able to communicate and use all these two services like IMS and data with the core network. Then it will send its registration with tracking area update, whatever we have discussed in the initial context, like that to handle the mobility management. There is a update always coming from the user side is called as a tracking area update. So TAU request always coming. So this is the part of MO signaling, mobile originating signaling. So after a periodic time, always this user requirement is going to send this tracking area update. So based on that tracking area update, core will let to know that this is a connected user, or I have to take any action, or need to release the context and all these things. So if this tracking area update is not come for a while, then core will reject this. Means core will start a paging, and all the activity will start. Also on the Wireshark, so we have enabled our logs also. So in the log also it will show that there is a initial message. So we are having various type of log level. So like you can only enable the error log, wherever the error will come it will print there. We have info logs where it will show the informational log. Also we have debug log where it will show the every line of log. Means this request started from here, goes there, from there response come, what response come, all these type of logs you can enable with the configuration file. So configuration file, you need to define the log level. Based on that, it will print the log on the log configuration. So initially we message we got. So now we have created a session like one gnode, one UI is go to register with the core network. Here it will print all this NJP UID, MF UID, from which area, from which cell it is going to connect, whatever Teams values it has requested, whatever is assigned to UE. So all this information is available in the logs also. From the logs also you can identify that if U is not able to register, so what can be the problem. So in the log will print all this information also. So here one by one so, it will show all the registration complete or 5G attached status, matrix publicity, which UI configuration updated. All this is going to print in the logs. So these are our log files. So similarly, this is for the AMF log file. We are having some other log files also where you can debug your messages. So these are total number of log files. Some is defined for 4G also, some is for 5G. So for 5G, basically there is NRF logs where you can debug like that which network function is not able to register or what is the reason cause for that particular network function why it don't go to register. Then there is PCF log where all the policy and authorization related information you can get. Means any access rights is there or any policy is having any issue. So you can debug that log from the PCF logs. So here it will show all the events, whatever is coming from the NRF and all other network function. So then there is AMF logs we have seen live. So all the messages coming from the UE. So this is the single entry point, so it can help us to debug that logs. Then SCP logs is there because we are we have registered our all the network function through the SCP to the NRI. So SCP is playing a crucial role in that also. So SCP log is also there. For session management, SMF log is there. Here you can debug all other things like how many PDUs are associated with which MC values. Here like data PDU and whatever the UE related information is there, like which IP address SMF has assigned to the UE for which particular DNI. All these messages are going to stored here. Whatever the this PCF validity period is there, UDM validity period is there. So all these logs we have stored here. And similarly, we are having UPF logs also. If user plane data related any issue is there, if any GTPU related issue or any other type of issue is there, it will print in these logs. So how many sessions are continuously running, what is the ID of those sessions you can debug from the this UPF logs. Then UDM log is there. Similarly, AUSF and UDR, BSF and NSSF. All these are 5G related logs can be seen. So, so this is all about all these things. So if I have any doubt or any other thing I have to explain, I can explain. हेलो, मुकेश सर आप हैं?
If anyone having any query, any question, please ask regarding core and
Regarding any module you want to understand a little bit more, so we can discuss about that.
GNDU Amritsar. Okay, Navjyoti. Hand raise is there from GNDU Amritsar.
Yeah. Shared that. We will share that information to them through TCL only. So I had already quoted that message over that public chat. So anything related to 5G core, yeah, in that protocol deployment, anyone can ask any questions here now.
Because we have 15 minutes and the next session is about the brief of 5G core network function we already discussed it throughout the session in the protocol deployment and all these things. So if you have any particular question, we can go with that.
At GNDU, I think you have more than one device on the same conference.
Hello.
Yes, sir. Please means switch off the speaker of other devices. Okay, because I think you have multiple devices there at the same place or same room.
So fine. Here the firewall session. Why this firewall we are using here in the 5G lab? It's a private network, but we are connecting our system to that public network also. So the monitoring and control incoming and outgoing network traffic need a security, so that we using this firewall system. There are a lot of traffic filtering type of firewalls are there. We will go by one, and we will show you how we can set these things through existing device number.
Okay.
Yeah, let's understand the use of firewall. Why we use firewall in the network? Let's understand this. So basically, when we want to restrict the traffic, the inbound traffic and the outbound traffic, we use the firewalls. So you can say there are multiple protocols like HTTP, web, SSH. So if you want to restrict any one from the outside to access the local resources, we can use firewall, and we use firewall rules to restrict this. This is the purpose of the firewall. So let's go through the options that we use in the firewall to monitor, to restrict the traffic, right? So let's continue and logged into the device.
Username is admin and the password is admin at the rate 321. So this is the dashboard of the firewall. Primarily, you can see here the CPU type, memory, cache memory used, and the disk space.
कर दो उसमें कर दो हाँ ठीक है ठीक है उसको मैनेज कर ये क्या है 2 मार्च को
मुकेश सर आपका माइक ऑन है, जरा बंद करिए. Then how we have implemented this firewall for the internet connectivity. So you can see here in the interface section, there are two things. One is LAN and one is WAN. So this is the configuration of the WAN side, the internet which is provided by the institute for the 5G lab. Here you can see here, there are two modes. One is DSCP and one is static. If institute is providing static IP, so you can put it here as a static IP. Option will be selected from this drop down, and this is the IP address. Save from here, and this is the LAN side. Again, this is the static IP as per the IP scheme which is used in your network or 5G lab. This will start the internet connectivity, LAN to WAN routing, and rest of the things are the how we can use the firewall features. So, Mr. Rishi from Coral Telecom, he will elaborate all the things.
Yeah, the firewall works at the gateway level. So here you can see the WAN interface and the LAN interface. LAN interface is the local site interface, and the WAN interface is the interface that is responsible to interact with the other world. You can say cloud or any ISP network. Okay, so here is the configuration how to setting up the WAN interface and the LAN interface. So you can see on the left side there are many features like routing, and there are multiple protocols. This is the firewall where we can see the rules. These are the VPN options. So let's discuss one by one. So if you want to restrict a specific traffic, suppose uh, you want to restrict a domain based traffic, suppose you want to restrict google.com, then you can create a rule to restrict this traffic on the basis of domain. But if you will deny the traffic for the port 80, that is a well known port for the web server, then it will deny all the traffic that is destined for the port 80. Nobody can use the web traffic if you disable the 80 port. So the better is to restrict a single domain so that only a single domain can restrict for a specific user. So how we can do this? Let's go to the option.
Go to the services and there is an unbound DNS. Here, it is a block list. We have restricted the site github.com. Put it here, apply from there, and restart the service. And then try to access the github.com.
So you can see here, this site is not reachable.
So in this manner, you can block the various domains so that user can not access the sites that you have under the denial list. So here are the routing protocols. If you have multiple networks in your LAN part, suppose I have multiple devices like IP phones, servers, and you have separate network. So to access between these network, there are multiple protocols that you can use for the communication between these networks. Either you can use the static routes, but if your network is very large, you have to use this routing protocol. So these are the dynamic protocols that we use for the communication between the networks. So the very first protocol is RIP. It's a routing information protocol. So this protocol works on the hop count, and the maximum hop count is 30. So after packet will count the hop by hop. If it doesn't deliver after 30 seconds, it will destroy itself, so that it doesn't continue in the network to avoid any loops. So the next is, this is the configuration you can create. There are two versions. Version one is absolute, and we are using two. And these are the configuration route restriction. If you want to restrict any route, what network you want to go for, this is the option for that. Metric is a parameter that we conclude when we uh, send the packet. There are alag metrics, different metrics for separate protocols. So another is OSPF. This is open short path first protocol that works on the best, finding the best path. So it is responsible for that. And this is the configuration to configure the OSPF. If you want to enable this protocol, just check mark that this protocol enable, and another are the options that we need to configure uh, to make it functional. So other is the BGP protocol, that is border gateway protocol. So when there are multiple cloud side ISP, so if you want to work with that ISP protocol, you have to work with the BGP so that it can interact with the other autonomous domain. That is the outer part of the outer part of your network. We use BGP. So other is the VPN. So VPN is the most important part when we are using the firewalls. Suppose you have offices, one is the head office, one is your branch office, or you can say one is your physical office here, you can say in Noida, and one is the machine that is situated in the cloud, anywhere in the world. So you want to share the traffic between the head office to the cloud machine securely, then we use the VPN tunnels. So there are two protocols. One is IPsec, that is IP security. This is the very most useful protocol that we use to create the tunnel between the head office and the remote office. So there are many protocols when we configure the IPsec. Discuss one by
Hello,
one.
excuse me, sir.
Yes.
Sir, please make it full screen.
Your voice is very fuzzy.
Yeah. Can you please repeat? Hello. Yeah. I am audible.
Yes, yes, sir, you are audible. Yes.
Okay. Okay. Shall we continue?
Yeah, yeah, yeah.
I
Oh,
think Mr. Kamlesh Bhatt. Kanush Bhatt want to ask something. Kanik sir, can you repeat it again?
Yes, sir. Please continue.
Okay, thank you. So, let's continue with the IPsec. So this is a side-to-side VPN. So side-to-side VPN means so you have multiple VLANs or multiple network running on the LAN side. If you are working in cloud, any branch, there are multiple network side also. So transfer the secure traffic between the both locations. We use site to site VPN, that is IPsec, so that the multiple VLANs can communicate with the multiple VLANs of the remote site. So let's talk about the encryption type we use. We use AES 256-bit encryption to encrypt the traffic over the secure tunnel, right? So it also uses IKE, Internet Key Exchange Protocol, that is responsible for securing and make sure that the data is not tampered. So this is a protocol IKE that is also required, so that it validate that the both end have the similar protocols, so that the tunnel can create. If there will be any different protocols at one side and other side at different protocol, then the tunnel will not connect and it will not functional. So it makes sure that both side have the same protocols. So other is open VPN. So this is a SSL type VPN. Suppose you have a firewall and you have only client. You don't need to connect the site to site VPN. Just create a profile and use this Open VPN. It will connect your laptop or any single machine with your network. You can access complete network from your laptop. So these are the VPN types, and other are services in the firewall. So these are the services related to the firewall box. So this is the network time protocol that is responsible syncing the time, and this is intrusion detection. If someone suppose there are DOS attacks, so it is responsible for monitoring and disabling that type of traffic. And if you want to monitor the logs from the firewall box, these are the options. You can enable these options so that the syslogs that generate inside the box, you can view that logs and can monitor that traffic, actual traffic that firewall will pass through from WAN side to LAN side. So you can enable the logging. And
One more important setting is there, the DSCP provided for which will be connected to the 5G labs. So there is an option DSCP LAN. Here you can define the range. Let's suppose I am defining the range from 15.201 to 15.250 and the gateway. Save the configuration from here. After saving this configuration, always remember to restart the service from here. After this, when you will put your laptop on a DSCP mode, the IP will be provided from the range of 201 to 250. So that will also prevent you for the IP conflict. This is the web address, IP address of the firewall, and port number 3000. The credentials are the same, admin, and the password is admin at the rate 321. This will provide the real time statistics of the firewall. What is going on the firewall? What is the traffic? What are the protocol you are using? If you will go to the flow, and this is the live flow of interface IGB7. IGB7 is our WAN interface. So you can see here various traffic is going through the firewall. Mr. Rishi will elaborate everything
You can
regarding.
see from this page, there are many protocols that are using through the firewall. There are TCP protocols, ICMP. Someone is maybe pinging. These are the UDP port, TCP ports, and in the other column, you can see the which server is using the which type of traffic. You can see here is a SMTP, NTP time. Network time protocol, and this is a HTTP traffic.
Hello.
Yes.
So we are not able to open this 3000 port. Like we are putting 192.168.28.1. Our is 21 octet, and we when we put 3000, it says connection timeout.
Can you make sure if your device LAN port is connected in the switch?
Yeah, yeah. We are going to we can see the interface, the another interface
Okay.
without 3000 port,
Okay.
and also yep.
Uh, in which lab, sir?
G and U.
GNDU. Amritsar. Okay. You are not able to open the 3000 port
Yep.
for traffic monitoring.
Yes, sir.
Okay, no problem. We will.
Sir, we will connect you separately. I mean, Ajay will help you out how to connect
Also,
that.
there is another change, like the logo in the last page. They are changed, not from Coral. It is some another thing. OPD
It is from
sense.
Cosgrid, sir. This firewall is of Cosgrid, not of Coral.
No, no, not Coral. The logo. Can you please go to the last page, last web page?
Yes.
Yeah, on the top left corner, there is written Cost Grid, right?
Yes.
Right.
In our web page, it is written OPD sense. Can I share a
Oh, okay.
screenshot?
Send it to Ajay directly.
Sir, we will connect you separately, and we will take a remote from your system, and we will show sadly that 3000 for
Okay.
how it is connected and all. Ajay,
All
will
right.
connect. Okay, thank
Thank
you.
you.
So this is the dashboard where you can see the application, protocol type, which client is using which application, and the duration the session is connected from the last time. So you can see this type of information from this page. So these are the bar graph where you can see the different type of traffic in the chart forms. So these are the host in the top host, which the host that consume the more traffic than the other users. So these are the application types. If you will see the top application section, network discovery. So in this page, you can see the MAC address of the host and the IP address. You can see here. Basically, this dashboard is responsible only watching the live traffic. It is showing by different user type, IP address type, MAC address type. So this is the easiest way to view the traffic.
Line, code wise.
So here you can see we have selected the interface, the named IGB6. This is a LAN port. So if you want to monitor the traffic for that specific LAN port, here is the option. You can select the interface from the above drop down menu. These are the help tab where you can see the documentation if you stuck somewhere and if you want to know about the specific term or any option, then you can go through this help menu also.
सर आईडी शेयर कर लो सर आईडी आईडी वो जो का रिमोट लेने के लिए अल्ट्रा
So in the above, you can see some kbps traffic type. So it is showing the inbound outbound traffic on this specific port. How much traffic uh, it is passing for the inbound and what type of traffic it is passing outside this port, inbound and outbound.
The throughput of the firewall. How to check? First of all, check the WAN port. This WAN port should be in the overview section. IGV7 is configured as a WAN. First, check the connectivity. It is 100 Mbps, 10 Mbps, or 1000 Mbps. First, here you can see the connectivity of 1000 Mbps. Then you can check the speed testing for the throughput test. Just type the speed test on browser and go for the Opula and run the test. That will provide the upload and download speed. I think Institute has stopped this. So here you can see the throughput testing of the firewall. So it's showing 185 Mbps download and 835 Mbps for the upload. So throughput will be depend upon the what WAN network speed is providing via the institute or the service provider or ISP. For the taking the maximum throughput, this WAN port should be connected physically with the 1000 Mbps, 1 GB port. It supports 1 Gbps of throughput.
Throughput also depends upon the configuration of the box also. So what type of configuration your box has. So how many cores your box has, uh, how much memory your box have. So this parameter also depend upon the box configuration. And some throughput also depend upon the firewall rules also. So here is the option of ARP table. So basically, this is the mapping of IP address to MAC address, right? So this table shows which IP address has which MAC address, and you can also see the manufacturer of that MAC address also. So we already know this is 48 bit long address. So this is the OUI for this MAC address. This is super microcomputer, and the other one is Cisco. Then the EC2 is Dell. So this means that the lower two MAC addresses are for the servers. That are the Dell servers. You can see the make also. The above one may be a Cisco phone.
No, डेल के सर्वर है तो
नहीं Cisco.
ये वहाँ से आ रहा होगा जहाँ से इंटरनेट आ गया.
Okay. So this is the ARP table. You can say the IP to MAC address mapping.
Address resolution protocol.
Yeah. So this is the DNS lookup. Suppose you do not know what IP address this domain has, just put in the domain name in the box, and it will show you the IP address for that specific domain. So another is Netstat. Netstat is useful when we want to know the which IP address is associated with the which TCP port. It will show you the current listening TCP port and the specific IP address. Suppose when you want to troubleshoot the network, like when there are some problems and you want to capture the traffic and analyze that traffic, here is the option for packet capturing. So you have to define the port, interface, packet length. It will capture the packet, and further you can analyze this captured traffic for various purpose to troubleshoot the things and to block any traffic, right? If you want to suppose in a network the user is not accessible, uh, not able to access the internet, so to check that you have to ping whether the specific host is reachable from firewall or not. Then here is a command that is ping. Just type the IP address of that host. It will show you the ping count, whether it is successful or not. कोई IP है?
There is no noise.
See, we used to uh, IP addresses. One is 888, that is global DNS, other is google.com. So you can see there is no loss. So it means that it is able to ping the both. One is IP address, that is 888, and the another is domain google.com, that is reachable from your firewall. That means the WAN side network is up and running. There is no issue with the WAN side. If user is not able to access the internet, that means you have implemented any rule that restrict the user to access the internet. You have to check the firewall rules. Another is traceroute. Traceroute is another command to troubleshoot the network. Yeah, this is traceroute. Traceroute will show you the path router by router. Suppose if you want to show the destination, the IP address that you want to access, where it is currently, then you can use the traceroute command. It will show you the complete router path, and you can see how many routers are there from source to destination. So basically, traceroute is responsible for when we are working on the WAN side. Because if you will traceroute in the local network, it is a directly connected network. It will not show you the router because there are no any separate networks. You are working in the single network. You can see there are five routers between your firewall and the target IP, that is google.com, right?
Just a second.
So this is a firmware option. So suppose there is a latest update from the provider, then you have to update the firmware also. Here is an option from where you can update the firmware. So updating the firmware is very necessary because from the vendor there are day to day they added the upgradation, and to resolve some vulnerabilities, they have the new feature in the firmware. So always update your box with the latest firmware.
One feature is there for the load share and load balancing. If in the lab we have multiple of service providers, right now in most of the labs we have institute is giving us the WAN address for accessing the internet. If institute have more than one ISPs, also you can do the load balancing. Load balancing can be achieved by this. Go to the gateways. Let's suppose there is right now we have the single gateway. So you can add here multiple gateways. These are the settings. In the group also, these are the settings. So load balancing can be also be achieved here.
Hello.
Hello, yes sir.
Yes, sir. This is the load balancing of incoming traffic, I suppose.
No, multiple service providers. Let's suppose you have Geo, you have Airtel, or you have some other ISP. You can configure in your firewall, and traffic will be balanced. Let's suppose traffic is reach your Geo connectivity is of 1 Gbps, Airtel connectivity is 1 Gbps, and other ISP connectivity is 1 Gbps. And internet using in the manner that the first Geo is reaching to the 500 Mbps. So then the firewall, what firewall will do, that will route the traffic to the distribute the traffic to the another ISP like Airtel or some other. This is the load balancing.
So basically, it will help that improve the network performance, reliability, and resource utilization. We can say. So if you have multiple WAN connectivity, internet connectivity, we can make it as a load balancing to make the traffic move in that way. So it is obviously it is routed only for the load balancing only. This way we can configure.
Can is there any if we are having a single service provider and we
Mhm.
have to load balance the traffic to the servers within our firewall? Is there any option available like that?
This feature is for multiple WAN connectivity, so it is not for a single internal thing. So
Sir, suppose you have multiple ISPs connected on the box,
I got
right?
that. I got that.
So it doesn't mean if one traffic is passing through the only one specific ISP, then the other two ISP lines are idle, right? So the better is just load share the outbound traffic so that they can equally utilized.
I got the point, but I was asking something else. You are talking about the incoming traffic that is from the service provider, I suppose. Yes.
Incoming and outgoing both the traffics, which
Both of
is
the traffic that we are going from the
One
system
minute, Naveen,
to the service
please hold on.
provider.
Dear all, there is a link available in the chat box. Okay, please join that link for half an hour. Then we will continue this training session again. Okay, but for next 30 minutes, please join all available participant in this meeting. Please join that link first. Sunil, Naveen, join that link.
okay.
Then we'll
okay,
come back to this link.
Okay. कौन सा है?
feeling that.
Just one. Hmm?
Two.
इसमें मैसेज आ रहा है, you have been removed to the from the conference.
Message here, sir.
Hello?
Same message. You have been removed from this conference. Shubham sir provided. Sir, they have provided new link.
Hello. Okay, cool. Yeah, this one over. Wait.
Shoaib sir, can we start? Shoaib sir, can we start?
Yes, start now.
Yeah, fine, fine, fine. So we completed that firewall. If any queries related to that firewall, you can ask me now. So the next session is for NMS, Network Management System. That Rishi will take that session, and how do we configure this NMS? How do it is connected to that 5G core and or how it can be shown in that things we will shown here. So Rishi, please tell.
Yeah, hello everyone. So, current topic is NMS. So, let's take a little bit brief about what is NMS and what it does. So, basically, NMS is used to monitor and manage a various network components and devices within an organization infrastructure. So it provides administrator with the tools and the functionalities to ensure that the network is operating efficiently, securely, and optimally. So basically, we monitor the network components that are connected uh, using switches, routers, etc. So, what are the key functions of NMS? So, the key function of NMS are monitoring, fault management, reporting, right? So, in monitoring, we track the health and the performance of the network devices, such as switches, servers, IP phones, and other networking hardwares. So we collect the real-time status of the devices, and that we show on the NMS dashboard. So next is fault management. So fault management means whenever there is a outage or any uh, network issue, so we collect the alerts on a NMS dashboard as a active alert. And what is the issue that we can see from the alert history. So it shows the every failure and the cause, what actually the reason behind the device down. Is there any link down or it is any other reason? So we can keep track the outages in our network. So there is a option of reporting also. So in reports, you can download the reports of the date wise. So where you can analyze actually about the network performance, right? So this is the dashboard. So let's log in into the dashboard. So one more thing I want to add about the network NMS architecture. So there are two, three components by which the NMS server works. So one part is the server part, and server part is responsible for collecting all the device status and analyze that and show in terms of reports and on the dashboards. So it is a central part for your entire network and is responsible for the monitoring purpose. So another are network devices. Network devices are the devices to whom we need to monitor. So it can be anything that has an IP address. So this can be a IP phones, they can be a servers, they can be a any other device. And the third component of the NMS is a protocol. So protocol is very important while monitoring the devices. So there are two types of protocol. One is SNMP and ICMP. So we use this protocol to take the status of the devices to show on the NMS. SNMP stands for Simple Network Management Protocol that we use to get the health from the managed devices. And the other is the ICMP protocol, that is Internet Control Message Protocol, that works on the ping utility. So we continuously ping the devices to check whether the device is up or not in the network. So whenever there is any device down, we get the response fail as a ICMP, and we generate the alert as an active alert, and we generate the notifications also. So let's log in into the dashboard.
Uh, Give me 2 minutes. Some network connectivity is down from the lab. We are restoring the connectivity. हाँ चल रहा है. Hmm. Hmm. Rishi, sir, you can continue.
So after logged in into the dashboard, you can see there is the option of NMS. So just click on the option of NMS, and
Please hold on.
Yes, Rishi sir, you can continue. Right now it is locked.
Yeah, here is we are on the dashboard for the NMS. So there is an option. So just click on this option, and these are the various options that we use to monitor our network. So here you can add the location for the NMS. Suppose if you are in. So location means where actually your NMS is situated. So you can see here the location name is IITR 5G Lab, IIT Ropar. So the location of the current NMS is IIT Ropar. So if you are on any other location, you can go to this option and add the location where the NMS is situated. So another is asset. Asset means the devices that are connected into the network. So this is the asset. So you can create the asset inventory for the NMS, like what is the IP address, what is the name, and where this device is connected in the network. You can add this information as an asset. There are various column. You can see the name, IP addresses, the category, whether it's an IP phone, whether this IP belongs to the server, whether this IP belongs to any other device like it's a switch or it's a router. So this is the location. All devices are in comes under single location, that is IIT Ropar. Another column is the switch IP, means which device is connected behind which switch. So this column tells you about this information regarding the asset. So if you other option, see the column is notification, means the notification is enabled for all the devices. Means if any devices gets down for any reason, maybe any link down or maybe any hardware failure, you will get the real time alert on the NMS. So here all notifications are enabled for the NMS. Here is a discovery option. Discovery means whenever you connect your NMS or configure your NMS first time in a network, the NMS doesn't know about your network devices. You have to tell the NMS about your network series. So maybe if you are using VLANs, there are multiple VLANs. If there are multiple VLANs, means there are multiple networks. You have to add each network one by one, so that after adding these virtual network, the NMS will start discovering the devices in the VLANs, and it will show you as a device in the NMS portal. This is a reference as a discovery. So this is the page for the NMS alert history. So NMS alert history means it show you the real time alerts, right? And it will also show you the severity of the alert. So here is an alert. You can see the column it generated on this specific date. Alert closes on this. Service was ICMP, mean there was a issue with the cable or a net device down. This is a asset name, that is G node B. This is category, no one has defined the category yet. Another is IP address, and the severity is major. This window is very important when working with the NMS, so that you know about what devices in your network are down and what devices in your network are up, and you need to further troubleshoot the reason behind the device down. So here is the option for the SNMP. You can configure the rules for the SNMP. These are used for only managed devices like managed switches and servers, so that it can retrieve the SNMP data from the devices, like status and the location, health, the port status, everything. So here is the option to see the tree topology of your network. So these are various components. So basically, tree topology means how the various components and the devices are connected in a network. So basically, it shows the relation between the parent and the child. Here you can see the left side, there is the location, that is IIT Ropar. Further, there is a switch and NMS, 5G core, G Node B, MEC Cloud Core, MEC Edge Core, drone, MEC camera. All these are devices connected behind this switch. And there are two UE that are connected with the G Node B. So basically, this representation means the topology view and the relation between your parent and a child, so that you
Sir,
can, yes.
uh, how have you arrived at this page, sir? Can you show us again from the dashboard?
Yeah, yeah, sure, sure. You have to click on the three dots on the right side and just goes down, and there is an option of tree, and select the tree view. Down. Check it. Yes. Give me a minute. So now these two UE are in red color, mean these are not latched with the radio. So these are currently down. So let me show you once it latched with the radio, and it will show you as a green, means it is latched and up and running. So give me a, few minutes. So let's move further. Someone is trying to latch the UEs.
I'm doing the MEC down to check the health. So this is the MEC drone, and I am powering off this system. So you can see here, when I shut down the MEC drone, the status has become red.
And you can also see a notification if you see
Right side.
the lower right side. So there is ICMP MEC drone is status major. So it's a real-time alert from the NMS so that you can further troubleshoot what is happening behind this machine, why it is down.
क्लास कैटेगरी कैसे डिफाइन करते हैं?
So here is another option to monitor the services. Services like web service, HTTP, SMTP, SSH. You can add the option here, right? So that the NMS can start monitoring the service. Suppose you have a web application running on a server and the responsible port is port 80. So you want to monitor that status for that port 80. Just add here so that it can start monitoring for the port 80. So port 80 is for web services. So another ports are SMTP ports and SSH 20, ICMP. So here is the dashboard for the alerts. Here you can just this is the pie chart. You can see in the right side. This is for ICMP services. The alerts that are uh, coming due to the ICMP means these devices are down for this protocol. And on the left side there is a device summary for the, see, there is the application server, this is the call server, this is a switch, this is one RLU, and there no one has defined the category, and these are the alarms that has been generated for the IP addresses, that is 26.88, 26.83, 26.22, and this is a device name, status is down, and alert was generated on this specific date. Same, no one has defined the category for this. Protocol is ICMP and the severity is major. ICMP means the connectivity is down. Connectivity is down maybe because of the device, maybe any powered off, maybe any network cable fault, or any switch port issue. There could be any reason. So this is the page where you can see the alerts. So here is the option for the notification. If you want to receive the notification on the mail, you have to define your mail ID so that the NMS can start sending the notification on your mail. So here is the option to configure the mail account. So here we have given a email ID like new@coreldelhi.com, the mail password. This is the server SMTP URL, and this is the SMTP port. The protocol is SMTP. This is the name by which you will receive the notification. So another, let's go to the another option. So I think we have covered all the points related to the NMS. So even if someone has any query and any question, so please ask so that we can proceed further.
ठीक है सर, ओके मैं लेता हूँ। जी सर।
कौन तो?
शोएब सर, शोएब सर, शोएब सर,
जी
are you
हेलो.
there?
Yes, yes,
Sir,
yes.
Can you give presentation rights to Navjyoti?
Yes, yes. Srikant bhai. Hello, Srikant bhai. Srikant bhai, please give. नो ज्योति। वहाँ क्यों बैठ गया बंदा? हेलो श्रीकांत भाई, नवज्योति को दे दीजिए ना। नवज्योति कहाँ बैठे हैं? आ जाइए ऊपर यार, आ जाइए, दे दीजिए पहले। हाँ, नवज्योति TY है, सर्च कर लीजिए ना। ठीक है।
Okay, I think it's done. Navjyoti, can you check? You have the presentation rights?
हाँ कर रहा हूँ, एक मिनट। Is my presentation is visible?
Yes, sir.
Okay.
यस यस।
So good evening, everybody. So here we are going to give a brief overview on the Wireshark tracing and testing, all these type of things. So we will check how we can measure the packets through the Wireshark and what can be done for log analysis and all these type of things. So here is a brief introduction about this. So what is a Wireshark? This is a network analysis tool where we can capture the packet coming to a system interface and we can debug our problem through that particular packets. Then key feature and functionality. Then key feature of Wireshark is that this is a analysis tool only. Login. We can do log analysis through the Wireshark, like if we are going to connect two equipment in a network and if they are having any issue in interfacing, so we can debug through the Wireshark. So here is some graphical representation of this. So Wireshark basically is an open source network protocol analyzer used for capturing and inspecting data packets traveling over a network. It helps in network troubleshooting, security analysis, protocol development, protocol debugging, testing, tracing, all these type of works it can do. So it's originally named as Ethereal. It was renamed Wireshark in 2006. This is the history of this Wireshark. So why Wireshark is important? So whenever we are going to develop or interface two systems, so then we are going to face some problems while interfacing or while developing a protocol or while troubleshooting a network equipment. So at that time, Wireshark plays a crucial role in debugging. So what it does real-time packet capture, monitor network traffic in real time. It can do support multiple protocol. So widely used protocol like TCP, UDP, HTTP, SCTP, NGAP, S1AP, all these protocols are supported by Wireshark. Broadly, it support more than 2500 plus protocols. Help in security analysis. So with the help of Wireshark, we can detect suspicious activity like cyber attack or unauthorized access. So we will get to know by analyzing Wireshark that there is some unauthorized access or there is some attack on the network. So that we can debug on the interface level. Then this is a troubleshooting tool. It can diagnose slow networks, performance, drop packet and connectivity issues. Sometimes what happens that some packets coming to the network interface but it is not hitting to the application or some other thing, so that can be debugged at the interface level through the help of Wireshark. So it can help us to troubleshoot our problem. So these are the key feature and functionality of Wireshark. So one we already discussed like real-time packet capture. So through the help of WhatsApp, we can capture the real-time traffic which are coming on the various interfaces. So we can capture the packet on the local system or as well as on the remote system. So it allows user to analyze packets data in the real time. Then protocol support, like we already discussed, it support over 200 to 2500 plus network protocol including TCP, UDP, HTTP, DNS and more. Automatically detect and decodes protocol structure. So what it does, if we send a packet in the network, it is in the binary form, so it has the dissectors to detect the protocol structure. So for a human being, it is showing it as a human readable forms. Then there is filtering option is there in WhatsApp. So if you want to capture it or we want to trace the particular type of packets, like port 80 packet is there. Port 80 widely used for web applications. So if you want to debug like that our web application packet is reaching to server or not. So we can debug this with the port 80. This is a HTTP port. Then with the help of capture filters we can filter it out. Then we can do some color coding and all these type of things. We can highlight a command or we can highlight a protocol type of things that this particular protocol will be highlighted in a different colors. Then it helps us in some various type of functionality. First one is deep packet inspection. So examine packet headers and payload for detailed analysis, help in diagnosing network and security issues. So Wireshark is giving us a complete structure of protocol in a human readable form, so we can debug our complete packet and we can find out in the network element where is the issue with the help of Wireshark. So it helps us in deep packet inspection. Then second one is packet reconstruction and export. So what we can do, we can rebuild entire network session for analysis, export data in format like PCAP. We can store it as a PCAP, store it as a CSV, XML, JSON, and some other forms also. We can export our data for the later on analysis. Then security and network troubleshooting. So it can detect network anomalies, drop packet like whatever packet dropped on the interface level, it can show that packet also. Latency issue is it can identify. So it packet which packet takes more time to reach to the network interface. Then it can identify suspicious activity like unauthorized access and cyber attacks. Help in forensic investigation, penetration testing. So these are the key features which we have discussed as of now. So what is the conclusion of this particular thing? Wireshark is a necessary tool for network engineers, security analysts, IT professionals. Means with the help of Wireshark, if protocol developer is there, so he can debug their packets like what he developed is coming to accurate form or not. Or any other type of network related issues, it can be debugged through the Wireshark. Then log analysis. Wireshark packet capture help us in logs analysis. What is log analysis in Wireshark? Log analysis in Wireshark involves analyzing captured network packets to diagnose network issues and detect security threats. So this is a key feature of Wireshark. So it can do log analysis also. Every network packet is logged and can be inspected for anomalies, dropped connection, and performance bottlenecks. So it helps us in increase the performance of the particular system. So why is packet capture important? It helps in troubleshooting slow connection, packet loss, unauthorized access, and it assists in security analysis by identifying unusual traffic patterns. So sometimes it is happening that our network goes slow, so we can inspect our packets through the WhatsApp and can take the necessary action against that. So it provides detailed insight into network behavior and communication protocol. Also, if we want to check the details of particular packets, so we can check in the WhatsApp. So before starting the Wireshark application and continue with packet tracing, make sure to encrypt command on the 5G core. So there is a utility called in the Linux named as rpkpt. So we need to, if we want to capture the remote packet, we need to enable that. So we need to run a command rpkpt for that particular things on the server side. So here is an example of this rpkpt we have run on the server. So with the help of rpkpt -nd means this has to listen for the remote capturing. So with this command, what we can do, once we will run this command on the network, so from remote pc we can capture the live packets of this particular system. Then there is some instruction for the wireshark, like double click on the wireshark icon to open it. Then we have to go to the capture option, and inside the capture there is options. We have to click on the options. Then we have to click on the marriage interfaces. Then we have to go to the remote interfaces. Inside the remote interfaces, we have to click on the plus icon. In the plus icon, once you click, it will open a window. There you have to enter your server IP address. Once you will enter your server IP address, then this interfaces, it will show how many interfaces are there on the server side. After this, we need to click on the OK, and then here it will list down how many packet interfaces it is going to capture the packets. Then we can click on the start, and this live Wireshark is going to start on the system. This is some packet capture for VNR call. This first one is the packet capture of UE registration. In the filter type, like we have discussed about the WhatsApp, that there is a filtering mechanism. So here in the search bar, you can click, you can type your protocol name like NGP or SCTP or TCP or UDP, whatever type of protocol packets you want to capture, you can click on here. Like in the 5G, for UE registration or UE communication through the radio, there is a protocol called NGP and NES. So we will filter it out as a NGP protocol, NGP, next generation application protocol. So this is the packet capture we have attached. Here is the initial UE registration. So whenever UE is going to connect with the network, this type of packet will flow in the system. So we can help out, we can debug this packet with the NGP. If there is any issue, so we can find out it from here. Then there is one other thing is VNR call from UE1 to UE2 via Wireshark logs. So for VNR call, we are having a protocol called as a SIP, Session Initiation Protocol. With the help of this SIP protocol, we can analyze our VNR calling packets. So, like here, we have made a color coding also. In the first line, it is coded as a black color. So it is showing in the black color. So SIP HTTP invite packet, then it is going to trying, then 200 OK, then second is going to initiate, then session in progress and 200 OK. So after that, both is able to talk to each other. If there is some problem, we can debug it through the Wireshark. So now we can check the live training on the Wireshark. So I can show you some example packets and how whatever we have read so far, so we can capture it on the live Wireshark. So suppose like that, I have a server here 7.221 is my server IP. So first I will take the access on the server. At the first, what we have to do, like in the presentation, it shows there. We have to run the rpkpt command on the server side. So first we will run rpkpt space -nd command on the server side. So we are going to type a command rpkpt space -nd. So it will show that address is in UD, or if it is not in UD, it will start listening on this particular address. So this type of line will come. Then our next step is we have to open the Wireshark. So we have clicked here. we have opened a Wireshark. So this Wireshark got opened. So in the next step, we have to go to the capture option, and then we have to click on the options. So in the Wireshark, here is the capture option. Then you have to click on the options. So this type of window will open. Then next step, we have to click on the manage interfaces. Then we have clicked on the manage interfaces, and then on the remote interface. Manage interfaces, then on the remote interface. So initially, if you have not logged in so far, so it will show as a blank screen like this. So we need to click on the plus icon. On the plus icon, we will enter the server IP address. Like my server IP address is 7.221. So I will enter here. So how many interfaces will be there? It will show. So which interface packet we want to capture, it will show here. So suppose like that I have selected the whole. So now it will show me here as all the packets like loopback packets, Ethernet 0 packets, OJ external all virtual interface packets, so row IP packets. So I can capture all the packets, or if I don't want to select any particular interface, I can deselect it from here with the control. So it will show which interfaces I will select. Suppose like that I have selected all the packets. I will start. So it will start like this. So initially it will show without filter all the packets going through the server. It will show all the protocols and packets. So if we are going to capture the packets on the 5G side, we have a protocol NGP. So we will filter it out, NGP protocol. Then we have checked the initial UE message. So this is the initial UE registration packet. So here also we will register a UE. I'll show you the UE. This is our UE. So we are going to attach this UE on the network. So I have started this UE. So all the packet related to this UE come there. So there is an initial UE message, registration request, and then there is context setup request. If its context is already set it up and this authentication is already done, if its authentication is not done, then it will initiate some more packets like a UE authentication packet and then security mode command and then other things. So then radio capability and UE capability is going to exchange. Then context setup response will come. Then it will start a downlink and uplink. In the uplink, then it will send a PDU session setup request for the data connectivity. So this is the protocol NGP, and here we are going to filter it out. This how many maximum bit rate is assigned to this one, how many uplink is assigned to this particular UE, what is the endpoint IP address is, what is the GTP ID is there, what is the QS flow will be there. So all these 5K value and all these packets will come in the PDU session setup request. So what will be the priority of this particular PDU? Which type of PDU is this one? So all these details will show in this particular Wireshark capture. So then there will be one more uplink for the IMS registration. So then IMS PDU will get up in the same process. So similarly, it will assign on the IMS PDU also how many maximum bit rate and all these things, and what is the 5K value. All these will, like for IMS, there is 3.8 MB is the downlink speed, and for default data PDU there is 75 MB or 100 MB or 1 Gbps. How much you will configure? So this will create two PDU whenever you is going to get registered. After this, that you is going to get registered on the IMS over the SIP protocol. So second was the SIP protocol. So as soon as the IMS PDU set it up, it will show our SIP protocol here, and here we can debug the SIP messages if we found any issue. So this was our initial UI message. So now we can go into the detail of these packets. So like there is a IMS packet. After IMS preview, there is a packet on the IMS registration packet. So these packets came to the IMS. This is the registration packet from which it came. It will show this IMS URI like test 11 we are using. So it will show the domain as a ims.mnc, whatever MNC you are going to use. Then MCC, whatever MCC you are going to use, it will attach here and 3GPP network.org. This is the standard process of creating the domain by the Codes UI or some other mobile phones. So whatever PLMN you will configure, it will replace this MNC MCC with that PLMN, and this IMS request will initiate through the server via the UI. So from UI, it has initiated like you got the IP address 10.46.0.12 for this IMS PDU. So it has initiated it from there. Then the endpoint for this UI is port 5060 is our PCACF packet. So it has initiated this through PCACF. So this is the complete registration packet. It has various components like why header is there or max forward how many hops this packet can reach. So this is the maximum forward. Then security agreement is required or not. Then this sec agree packet will come. Then proxy secure required is not. All these will come in this one. So this will be the contact. Then whenever server has to contact to UI, so this will be the endpoints. So via this contact, server can contact to UI for any notification or whenever call is coming for the particular UI. So server will initiate a request on this particular thing. Then there is two header in the registration packet. From and to header will be the same because this packet is for the particular UI only. If we will check the VNR calling type of thing, then these packets will come separate. So that we will discuss in the VNR calling session is there. So in the IMS session, we will discuss all these things. So then there is how many can be the expire of this particular packets. What are the protocols allowed on this? Which are the methods allowed on this particular thing? So invite it can do, acknowledgement it can do, options packet it can support, then any cancel type of method it can support. So all these are the method types by update info FRP right. So all these are the packet structure. So first registration packet come to the PCSF, then PCSF will send a request to the UI back that I am trying. Please wait for some time. So it will send a 100 trying packet. Then PCSF will forward this packet to the ICSF. Then ICSF will send PCSF to that it is trying its request. So this 100 trying why we are sending, because if we send a 100 trying, then UI will wait for the some time. If we will not send 100 trying, UI will initiate a registration packet again, or some other device will initiate a registration packet again. So that's why we are sending 100 trying. 100 trying means please wait, your request in progress. So then from ICCF to SCCF, this packet will go. Then SCCF will validate that this UI is authenticated or not. If this UI is already authentic, having the authentication in the register packet, then it will simply send the 200 OK or rejected or bad credential, whatever will be the reason code, it can send. Otherwise, it will send 401 unauthorized to the UI back. 401 unauthorized means like in the 5G core network, we are having authentication request from the core side. So here in the IMS side, we are having 401 unauthorized to get the credential from the UI. So in 401 unauthorized, we will send some information to the UI. Based on that UI, we will send a register packet again. Then we will match the response sent from the UI and 401 whatever we have sent. If response matches, then we will send 200 OK to the UI. If not matches, then we will simply reject the UI that this UI is not authenticated. Once this registration process will completed, then SCC will send a notify to the UI for a particular mobile number. Like this is your MC number from where it is coming. With that MC number, whatever mobile number is binded, it will notify to that particular UI that this is your mobile number. Now you will receive calls or you can make calls from these particular numbers. So like I have binded 207 with that particular MC. So our MC was this 001019876543207. So our MC was 15 digit, and we have binded a 3-digit mobile number with that particular MC. So now UE mobile number will be 207. So then you will send, if it receive the packet, then you will send back as a 200 okay that we have received your mobile number. So this is the entire registration flow of this particular shape. Now we move back forward to the core side. So this is our core side packets we have captured. So let me restart the service so it can initiate all the packets here like authentication request. So we can debug all these packets one by one. So now I have restarted the core services. So core service means all the older information I removed, whatever in the case. So after that, I have initiated a UE registration. So first our UE initial UE message will come. Then it will denote as a which type of message it is. Like it is a registration request, and what is the establishment cause? Why it is connected? This is a MO signaling, means mobile originating signaling. So this is the initial message came from the mobile required a registration. So when this packet will come, then if code don't have the context of the UE, then it will initiate a identity request. Like 401 whatever we have seen in the SIP packets, it will initiate similarly unauthorized packet to the UE. Like that you are unauthorized, please give your identity. So after the identity request, it will send a identity response from the UE side. So what we will send in the identity request, some parameters we are going to pass through to the UE for the identity request. In the identity request, it will send back as the following information, like from which node bit came, what is its stacking area code, and what is the 5G mobility scheme with whichever it is going to use. Like it's MSIN number, which cell identity it came from, what is the tracking area code, and what is the payload ID from which it came. So it will send all these information to us. So based on that, we can identify that if this is a particular UE authenticated or not. Then once this identity response once this identity response completed, then we will send a authentication request. Then in the authentication request, we will send some parameter to the UE. Based on that, it will create its response for the authentication. So there are some authentication parameter like a random value will be there. Then AUTN will be sent to UE. Then AMF value we will send. MAC value we will send. This will be the combination of three value like AUTN is SQN, AMF, SMF. And one random number we will generate based on an algorithm on which it will create its value and it will send it back. Then some other parameters are there also like KSI AMF value is there. So three four parameters will be sent from the core side to the UE like create your response for on the basis of these particular parameters. It is suppose like that we have exchange a handshake like we will do the plus of two numbers, two person talk to each other and defined like a we will do the plus of two number. So whenever they were going to talk to each other, they will send two numbers. They knows the method will be adding both the numbers. So both will get the same response. So based on that, this authentication is happening. So then you will send this authentication response. So it will send a response message there. So with the based on the response message, we can identify that our response is matched with the response sent by the UE. If the values matched on the both sides, then we will send, take it as a authentication is successful. Otherwise, we can reject the authentication and give the particular code to the UE that credential don't match or whatever can be the reason. Once this authentication complete, then there is a packet called security mode command. It has been sent from the core side. Then core will ask you for the security. So core will request the IMEI request. In the security mode command, there is the requested value is the IMEI SU value is the major thing. And UE security capability that is also the part of this thing. So whatever things UE is supporting or not, then it has to expose. So IMEI request we will basically are doing in the security mode command. So we will get to know the physical identity of the UE. So here in the response, you will send back as the IMEI value. This I need to check why it is not showing. Other than that, there is IMEI SU value should be there. Means this WASARC is not able to decode this packet properly. Else it will show here as a IMEI SU value as well. Wait a second. Let me check. Oh, we have enabled the security. That's why it is not showing there. So this will be the packet after that. Like after security mode command, then there is uplink, and in this uplink, it will show the IMEI ASA value like this. Previously, there is the encryption enabled on the port side. That's why it is not showing the IMEI ASA value. So this security mode command, we are doing the physical identity request from the UI side. Then there is initial context setup registration request and initial context setup request and registration accept. After that, there is a video session informations are there. So you is going to request for the video session, like to how many services it can take. So based on that services, it is going to request the video. Basically, normal course users are going to register for the two videos. One is for data connectivity, another is for the this mobile calling. So you can say it is a for VNR calling. It is initiating for 5K value 5, and for data connectivity, it is going to initiate for the 5K value 9. In the 5K value 9, it will going to define that for which particular type of service it is going to initiate these packets. Here it is getting all these. Yeah, payload content. Wait. So here it will show the DNN for which particular thing it has initiated this video session request. So here it want to access the internet. For the internet access or data connectivity, it has initiated this 5K value 9. And here will the QoS flow description for this particular 5K value. So it will have its 5K values. 9 is for a default EMBB data connectivity. So it will denote as a 5K value 9. Similarly, for the IMS, it will initiate another video. Then here it will show as a IMS video, and its 5K value will be different than that, and DNO will be IMS for the endpoints. So here it will initiate for that. So here it will show that how many is allowed bandwidth on this, uplink is this, downlink is this, what is the pose for this, which type of video address is there, what is the IP address assigned to you for this particular video. So all these information will we can debug through the help of voice arc and all log analysis. So this is the deep packet inspection like that. We can select each parameter and we can find out where we are missing it out, or whatever is the reason means if we are facing any problem, we can find out the reason from here. So similarly, NGP protocol, we are also using the protocol called as a HTTP in the 5G network also. So we have time, so we will take some 5-minute session on this also. So there is HTTP2 protocol, as we have already discussed in the morning that in the 5G system architecture, we are going to use a unified communication protocol like HTTP only. So where each vendor can come together and can interact with each other. So this is the HTTP2 protocol. So we will filter out HTTP2 and NGP together. So we'll let to know the packet flow of this particular thing. Like as soon as initial UI message will come, core will initiate a UI authentication process. And UI authentication process, it will initiate to the AUSF. So first it will send a request to the SCP for the UE authentication. So this is the SCP address. Through the proxy, it will get to know that what is the IP address of this particular AUSF. Then it will insert the request next to the AUSF IP address, whatever it will get from the NRF or SCP port. Then all this packet flow will go like this only. So one request come to the NRF, it will resolve the endpoint address. Like I have to initiate authentication request. I will go. I need a AUSF. So for the AUSF, it will request for the AUSF. Then it will get the AUSF IP address. Then it will initiate the request next to the AUSF IP address. Similarly, if need a UE authentication, then first it will initiate to the NRF through the SCP. Then from there it will get a response. Then it will initiate the next request to the particular core network function, whatever is it has requested already. So like that, first request will go to the ASF, then next ASF request will go to the UDM, because all the data management is done by the UDM, and the UDM itself don't have the data, so it will request and it will send next request for the UDR. So this is the basic architecture, how they are, these two network functions are going to identify their which network function they are going to get. Like there is a discovery function in the network. Uh, there is a discovery function in the NRA. So anybody can get the send a request from the get that NRF discovery you want to do, and which NF instance it want, like UDM, and what is the service name it want to trigger. Like UDR service, it required target NF type from whichever it is, like UDR. So request feature also it can define. So based on this, NRF can select that what it has to return back to the requested NRF. Like here, UDM has initiated a request, so requested NF type will become UDM. Then for which NF it has requested? It has requested for the target NF type UDR. So this request initiated from the UDM for the UDR to the NRF. So UDM wants to know the IP address of the UDR. Simply in the simply word, if I will say, so next response will go for this packet. So here we go. So in the form of this NRF will send back the response. So it will send the member IP address, whatever member we have requested in our request. So it will send us the IP address. So based on this IP address, we will let to know that which UDR we have to connect for this particular thing. So all these other information it will also share, like whatever the key features of this particular network function, like it is porting, which PLM it is porting, what is the name of this network function. So all this information is coming to this particular array type form. So it will send these type of some parameters in the response, like what is the PLMN are there, what are the allowed NF type, which NF type it are allowed to connect to this particular thing. Like three NF types are allowed to connect to the UDR. One is PCF, one is UDM, one is SCP. So UDM can request to this UDR, PCF can request, and SCP can request. So this is the broadly idea about the VSR capturing, like how network functions are behaving with each other, and also how our call flow is working, like whether it is in UE registration or it is a IMS registration. So both are covered in this particular things. So if anybody want to know any other things, so we can discuss about this. Otherwise, we can close this session.
Any queries from anyone regarding Wireshark, how to set up Wireshark, how to see the logs? or anything. Yes, Sunil, if there is no query, nothing, then let's close today's training session.
Yeah, we can
We'll
wind up
start.
now. I think from TCL, sir, can we close now because there is no query regarding this. If anything, you can write tomorrow also. We are available from tomorrow or day after tomorrow. So maybe we can take another 15 minutes tomorrow for this, any queries related to today's session. And hopefully we can conclude today's session. From Shubham sir and from Shoaib sir, can we close right now? Can we conclude, sir? Shoaib sir, can we conclude?
Subham sir, anything else required, sir? Hello.
I think, Swapji, we can conclude, okay? So we will
Yeah,
start
yeah, you
tomorrow.
can. If any.
The session, okay? Tomorrow morning.
Thank you for the participants.
Thank you, everyone.
Thank you, everybody.